Number.
It seems like Mr. Namban has lost connection, Minir. Maybe we can start with the presentation, and then I'll be assisting you with the questions and the likes. Are you ready from your side?
Okay, no, thank you very much, Ndate Mohapi. Yes, from my side, I'm ready. I was just waiting for him to finish, but it's fine. I think we can continue with the presentation. I don't know, am I audible enough from your side?
Yes, you are. I do not know if you will be able to increase your screen.
The size of the screen.
The size of the screen, it seems very small. I just want to check with colleagues. Yeah, it's fine. I don't know. Maybe the issue is how you have shared the screen, but it's okay. It is visible from my side, and colleagues will indicate if they can't see anything. Mr. Lekhooa, I think you should start, Minia.
Okay, no, thank you very much, Ndate Mohapi. Colleagues, good afternoon. I really want to thank you for joining this marking guideline discussion. I think it is very important for us to come here and unpack, clarify, and standardize the marking guideline together, because at the end of the day, we want to ensure that there is accuracy, consistency, and fairness in our marking. And in essence, our goal is to improve together. So that is why it's very, very important to attend the sessions so that we can try and assist one another. But before I can start with the discussion of the marking guideline, I must indicate to the colleagues that we've noted that in one of the questions, specifically that was question 6, there was a 2 mark which was allocated to the statement. However, we are going to allocate that mark into those marks into question 7, and then at the end of the day, our paper will still be out of 150. Now, as far as question 1 is concerned, I did not receive anything from the colleagues. So as a result, our answers in question 1 will remain as they are. 1.1 will be C, 1.2 C, 1.3A, 1.4D, 1.5B, 1.6A, 1.7 will be D, 1.8B, 1.9D, 1.10A. So I think that Mohapi will take a round of questions, suggestions, and improvement after the discussion of question 2. Now, if colleagues can take a look at question 2, it reads as follows: 4 forces, force 1, F1, F2, F3, and F4 of magnitudes 10 Newton, 5 Newton, 8.66 Newton, and X Newton respectively act on a block as shown in the diagram below, not drawn to scale. So we are given a diagram indicating those vectors given above, or forces. Now in 2.1, it was required for the learners to write one word, one term for the following: the vector sum of 2 or more vectors, or a single vector having the same effect as 2 or more vectors together. So the answer that we're expecting from 2.1, we're expecting a learner to give their answer as resultant, and then we allocated 1 mark for 2.1. And in 2.2, it says, determine the magnitude of the horizontal component of force 1 graphically. So colleagues, Mona, the examiner was very specific to say the learners must indicate the horizontal component of F1 graphically. Remember, in the statement, we were given that F1, it's having a magnitude of 10 Newton. So now the examiner here wanted the learner to determine the magnitude of its horizontal component graphically. So here we have the marking criteria, whereby in order for the learner to get the 3 mark, number one, the learner must be able to give the correct scale, because we know that many a times learners will want to draw vectors without indicating the scale. Hence, we allocated a mark to the scale for the learner indicating the scale. That's where the first mark will be saying, for example, the learner will say 1 Newton is equal to 1 centimeter. So we'll give a mark for that. Now, on the second mark, we are saying that the horizontal straight line with an arrow, Kamanzuma will allocate the second mark provided the learner drew the horizontal straight line with an arrow using the scale that they've provided. So Kamanzuma, the second mark will depend on the scale that the learner has given. So meaning that mark will, the learner will get the second mark provided they provided the scale, and then when they've drawn the horizontal straight line with an arrow, then they will get the second mark. And then the last mark will go to the magnitude of F1x, meaning if the learner got their horizontal component as 7,07, meaning our range. Mr. Mappy, can you please assist me with the person that is making noise? Can you just speak the person? Okay, thank you very much, Mine. Yes, I was saying the last mark, if the learner got their answer as 7,07, the horizontal component, that's where the last mark will go to. But we have an acceptable range if a learner got their horizontal component is between 7 and 7.1. Therefore, the learner can get a mark for that. So that's how we'll mark question 2.2. And then in question 2.3, it says calculate the magnitude of the vertical component of force 3, F3. So it means in that question, how are we allocating the marks? Here we wanted the learner to determine the component algebraically, or you can say with calculations, meaning the learner will get a mark if they used that force because the force was provided in the question, and then they use sine as their trig ratio. But if they use sine, they will have to use an angle of 60 degrees. Go to in option 1, and then the second mark will go to answer when the learner indicate that force 3y as 7.5. And then in option 2, if the learner used the 30 angle, which the way it is given in the diagram relative to the y-axis, and then they use the trig ratio as cos, then the learner will get the first mark. And then also for the final answer here, the learner will get another mark. So that's how we'll allocate the 2 mark for that question 2.3. And then for 2.4, it says the net horizontal component for the 4 forces is equivalent to 1.59 Newton to the left. Meaning here, colleagues, we've given the learners the resultant for the horizontal component as 1.59 Newton to the left. And then the net vertical component for the 4 forces to the y, it will be 2.07 Newton upward. Meaning here the learners, they are given the x and the y component for the resultant. Now, the question says, the learners must calculate the magnitude of x. Now, if we can refer to our first statement given in the question, x is the 4th vector, which it was not given the magnitude. So now the learners must determine the magnitude of that particular vector, which is the fourth vector. So now, how are we going to mark this question? So we are going to have positive marking from 2.2, where the learner had to determine the magnitude of the horizontal component F1 graphically, and then also 2.3, where the learner had to calculate the vertical component of F3 algebraically or with calculations. So meaning as we mark this question, we will consider the value that the learner got in 2.2 as well as 2.4. Now, in option 1, how are we going to mark? So because the learner is given 1.59, the learner will have to equate that 1.59 to 7.07, which is the magnitude that they got graphically, minus 8.66 cos 60, which is now the component of the third force, which they would have calculated in 2.3, and then minus F4, which is the one that we want to determine its magnitude. And then for that substitution there, we'll give a 1 mark. And then for the second mark, that's when now the learner will have to do the calculations for the vertical component of the resultant. They were given the resultant as 2.07. If they equate the first force, which is F1 as 10 sine 45, minus 7.5 plus Fy. Now they will get a second mark for that particular substitution as well, meaning the learner, they get the first mark for the horizontal substitution for calculating the horizontal component of the resultant, and then they get the second mark for calculating the vertical component of the resultant. And then after that, the learner can get a value for F4A as 1.15, and then the learner can get the vertical component as 7.5. If now the learner put those values that they got from calculating F4A, the vertical component of force 4 and the horizontal component of force 4, now they will substitute them into Pythagoras. Then they will get another mark for substitution into Pythagoras. And then the final answer will get also another mark. And then with option 2, still the learner will be required to calculate again. But how is this done differently is that in this one, the learner will substitute force 1 again as 707, which is the one that they calculated in 2.2, substitute 0 for force 2, and then substitute negative 8.66 cos 60, and then minus. But here we'll substitute this component of force 4 as F4 cos theta. So that is where the change is with option 2. And then again, for the vertical component, the learner will have 2.07, substitute 10 sine 45, minus 5, minus 7.5, and again here, substitute for the vertical component of force 4 sine theta. So with the first option, we did not include cos theta for the vertical as well as the horizontal component, but here we are including cos theta for each of this calculation. Therefore, that's where the 1 mark will be still. But here, because of the sine and the cos, if the learner divide the first equation and the second equation, they will get tan theta, because if we are saying sine divided by cos, we are getting tan from the trig ratios. Then they will have to say 7.5 divided by 1,15, and then they will get an angle in this calculation. Then the angle that they will get, they will be 81.28 degrees. And then they will have now to use that particular angle that they got with either the horizontal component or the vertical component, whereby they will have to say for the vertical component, F was 4 is sine theta is equal to 7.5, and substitute the angle that they got, which is 81.28, and then get 7.5, and then at the end of the day, that force will be 7.5 9. Or they can use the horizontal component, substitute F4 cos theta equal to 1.15, and then from there calculate the force, which is force 4, and they will get it still as 7.58. Mr. Mahapi, I will pause here for question 2 and take inputs, suggestions. Thank you, Mene.
Menier, we have, I think, one question from Alota on the chat. But before we get to the chat, maybe we should take hands. I see a hand from, is it Melanie?
Hello, MTV, how are you?
I'm good, and you?
I'm good, thanks. I have a problem at 2 point, the one with the scale, 2.2. If the learner has no scale, the maximum mark can only be 1, ne?
Mr. Lekhooa, are you following him? Hey, Askis?
Oh, no, thank you very much, Mene. Yes, I had a question. Yes, meaning the scale indication there, it's very important. Meaning the learner will only get 1 mark, as she's saying,
Okay.
yes.
Thank you. And I
Okay.
have another question.
Okay.
At 2.4, I do not agree with your answer there. According to me, and I hope I'm correct, the 1.59 on the in the RX substitution should be a minus, because the question paper says 1.59 newtons to the left. So that 1.59 should be a minus if you look at the other directions on the other side of the equation sign.
Oh, are you talking about option 1 or option 2?
Both.
Or both options? Okay.
Yeah.
I think
According to me, then 1.59 should be a negative, and then my answer there at F4x then gets at minus 4.33. But you can just double check me on that.
okay, yes, I think the team will look
Mr.
into it.
Mohapi, can I come in?
All right, ma'am.
Yeah, it will be corrected in the memo. I also see she is correct.
All right. No, thank you very much. Colleagues, please take note of that question. That is what? Question 2.4, ne?
Yes, it's question 2.4, Mene.
No, thank you very much. Then it will be corrected, colleagues. But as you start marking, while we are still waiting for the memorandum, an updated marking guideline, please take note of that.
Okay.
Thank you. Yeah.
No, thank you very much, Mme.
Any other hand, colleagues? I do not see any hand. Lekhooa, we have questions on the chat, ne? From Alota. Alota is just asking for an explanation as to how we arrived to the answer for question 1.3, 1.6, and 1.7. If you can briefly just share with us.
I think we also lost Mr. Mohapi. We have a question in the Mohapi TV.
I'm still here, Mr. Lekhooa.
Okay, yes, Mene, I can hear you. You are saying 1.3,
1.6.
No, I'm saying, I don't know, am I audible? I think we have a network problem here. TV is also, we lost him.
Mema, I can still hear TV.
We can't hear TV, or is it me? Colleague, can we hear TV?
Yeah.
Yes, we can hear
Oh,
him.
it is me, eh?
Yeah.
All right. Yeah, if you can briefly, Lekhooa, just give an explanation as to how we arrived at the answer for question 1.3, 1.6, and 1.7.
Okay, 1.3, 1.3,
1.6, and 1.7.
1.7. Okay.
Yes.
No, thank you very much, Minir. I will start with 1.3. So 1.3, it says a 90 kg man stands on a scale measuring in newtons that is fixed to the floor of the lift as shown in the diagram below. Now the graph below shows the reading on the scale when the lift is in motion. So meaning the graph that we are given here is the graph that shows the reading on the scale when the lift is in motion. So in which direction is the lift accelerating during the first 9 seconds. So in this case, the first thing that the learner must do is actually to take the 90 kg, multiply it with 9.8, then they will get 882. So now after getting that 882, it's at 9. But now the question is about during the first 9, meaning it's considering from 0 to 9. So at that point, it will indicate that because we are having a value that is increased, which is 9.1. If you check that we are having 9.14, and then when you check the other value, it's 8.56, which is now, it means as this object is, why we are saying this object is accelerating upward, because at that particular point, we are a high value more than the actual weight that we are getting of the men when they are just standing, meaning between 0 and 9, it's indicating that the scale was moving upward because we are having an increased value of 914. But why not saying downward? Because at that point, if it was going downward, the value will have to be less than that 882, which is the actual weight of the man standing on the scale. I don't know, Mr. Mahapi, if I make sense on that question.
No, I see an indication of a sharp Minera. I think we can move on to 1.6. Minera, you have unshared your memo. You know. Your memo is not visible. Yeah, no sharp.
Okay.
Okay,
All right.
you can go to 1.6 and 1.7 Minera.
Yes.
You have unshared again. Oh.
Okay. Going to 1.6. 1.6, if you check 1.6, it says a conventional current flows in a conducting wire from X to Y as shown in the diagram below. The conventional current flows in a conducting wire from X to Y as shown in the diagram below. So we are given a diagram there. I think what the learner might miss here is an indication of P there. If you check P, it's at the bottom. So meaning if we are told that our current is from X to Y, it means the learner must apply the right-hand rule. But as they apply the right-hand rule, they must consider that we are having point P. Meaning what? If you apply the right-hand rule, for the top part, which is the part where there's X and Y, your direction of the magnetic field will be out of the page. But on the side of P, it will be into the page, meaning what is important there is to apply the right-hand rule. Make sure that you use the right-hand rule, not the left-hand rule. But with the right-hand rule, meaning the top part of the straight carrying conductor will be actually out of the page, but the bottom part will be into the page. I don't know if I also make sense here, Mr. Mahapi. Can they just indicate whether they get what I'm saying or not?
I saw another sharp Minera. We can move to 1.7.
Okay, 1.7. With 1.7, it says in the diagram shown below, a cell is connected in parallel to 3 identical bulbs X, Y, and Z. Switch S is initially closed. Ignore the internal resistance of the battery. So what is key here is that we are given a parallel circuit. Now, what is it that we know about the parallel circuit? We know that if we are having a parallel circuit, bulb X, Y, and Z, they will be having the same potential difference as that one which is given in the battery. So meaning whether the switch is open or closed, because of it's a parallel circuit, each bulb, the bulb at X and Y, they will be having that potential difference that is in the battery. So hence, when you open the switch, what will happen to the brightness of the battery is that it will remain the same. Why remain the same? Because the bulbs will still be getting the same potential difference that they were getting before, because these 3 bulbs, they are all connected to the battery, meaning whatever value that was in the battery, bulb X and Y, they'll still be having that particular value. Hence, it's very important to indicate to the learners that when you are having a parallel circuit, all the resistors will be having the same potential difference. So it means in this case, whether the switch is open or closed, those bulbs will still be having the same potential difference. Hence, we chose our answer as D2. Say the brightness will still remain the same for all those, with an exception of X now not showing any light because of it's no longer connected to the battery. Thank you. That indication whether am I clear or not?
No, that was perfect, Meneer. I do not see any other hand. I think we can then move. Oh, that there is another one on question number 1.8.
Okay, 1.8.
Yeah, 1.8. Mr. Alota will come to you. You are noted, Meneer.
Okay, 1.8. It says two identical resistors, resistor R1, R2 are connected in circuit 1. And then circuit 2, as shown in the diagrams. The power dissipated by each resistor in circuit 1 is P. So meaning in the first question, what we are having each resistor dissipating a power of P. And then in the circuit 2, we are not given any power, then we should decide to now what will be the value of R1 and R2. So what I would advise Mr. Mahapi in this question is that, firstly, you can either use the formula of P is equals to I squared R, or you can use the formula of V, I think it's V over, or V squared over R. So with that question, in the first circuit, meaning you will make your workings. After doing your workings, by substituting, when you calculate for power, you will get your value of 2P. Meaning what you can do what? You can firstly calculate the resistance in series for circuit 1 and get a value of 2R. Because we don't know the magnitude, you can just use R there for either resistor, and then you will get now a value of 2R. After getting that value of 2R, you go and substitute it maybe in a formula of P equals to I squared R. Then after substituting there, you will see that at the end of the day, you will have I squared into bracket 2R, and then you will take the 2 out, you will be left with I squared R. Then it means that you will be having 2 multiplied by R squared R, which will represent P. Now, that will be for circuit 1. And then for circuit 2, you do the very same thing. Calculate now your resistance in parallel. And then again, you can allocate R and R for R1 and R2, and then calculate your resistance in parallel. After getting the value of the resistance in parallel, you will get something like R divided by P. And then after getting that R divided by 2, you multiply the R squared with R, and then you will find that your answer there will be half I squared multiplied by R. And then you change that I squared into R into P. And then what you will do, you will take the value that you got on the first circuit, which is the old circuit. You got P there, and then you will divide it with the value that you get on the second circuit, which will be half P. Then you will get that at the end of the day, you will get a value of 4P. That's why we are saying at 1.8, our answer is actually B, 4P. Meaning what you must do technically, you must calculate the power for the first circuit and also calculate power for the second circuit, either using P is equals to I squared R, or either using P is equals to V squared over R, and then you divide the two, then you can get the value of your power that will be dissipated by the second circuit. I don't know if I'm clear, Meneer, or do they understand? Can I get an indication?
Yeah, you were clear, Miner, and I also think already one of V squared over R works perfect in this scenario
Yes, yes.
also. Yeah.
Yeah, you can use either of the two.
Either of the two, yeah.
Yeah.
No, thank you very much. Mema Latela, I saw your hand, but it is now down. Before we move on to question number 3, Alota, you had your hand up. You can just unmute and ask.
Mr. Mabi, good afternoon.
Yes.
My question, Mr. Mabi, Mr. Lekhooa has already alluded on it. Ne? I'm just a bit lost now, about the removal of the resistor in parallel. We're not considering that in this scenario.
You are talking to question 1.7, ne?
1.7, yes. I believe opening the switch there is removing a resistor in parallel, meaning the total resistance is supposed to be.
All right. Mr. Lekhooa, did you get that?
No, Meneer, can you just elaborate it? I did not
So,
get it. I was trying to look for the question.
Yeah, that is 1.7. Alota says that with opening the switch, we are removing a resistor that is connected in parallel.
Mm.
So the removal of a resistor, I think it means, or it wouldn't it affect then the total resistance of the circuit and the current and the likes. But I think you only referred to the potential difference, or the potential difference will still be the same, isn't it?
Yes, I refer to the potential difference will still be the same because remember,
because they are connected
initially,
in parallel.
yeah, initially the value of the resistor X and Y has not changed. Then even the potential difference has not changed for those particular resistors specifically in those branches. I'm referring to X and Y. You remember the resistance, it will still be the same resistance. And in this case, it will still get the same potential difference. Hence, there will not be change in the power or the brightness.
Yeah, I think that is what he was asking. But what about the current? I think the confusion is, but the current moving through the resistors, won't it change? Alota, am I anticipating you wrong?
Yes, you are correct, Mr. Mabi. That's what I mean.
Yeah, and then, yeah, the effect of the change in current, will it have the effect on the brightness? I think that is what Alota is alluding to.
Okay,
Yeah.
I think the colleagues can assist me, but I think because of when you refer to the formula of P equals to V squared over I, the resistance for that particular branch, 2 branches of X and Y, I mean, the bulbs X and Y will still be the same, as well as the potential difference will still be the same. Because in this case, why am I talking about potential difference? We must remember that we are having a parallel circuit. Hence, I'm focusing more on the potential difference to say it will not change. So as a result, I think the current there, it will not have effect. I don't know if there anyone that can explain it much better, maybe.
Yeah, maybe colleagues can come in, Lekhooa, or maybe yeah. I get what you are saying with that. Yeah? So is there anyone who would like to come in?
Tatento, can I just assist? But Lekhooa is right. Ne? The current, yes, will change, and also the resistance, but the potential difference remains the same. Hence, the brightness remains the same. And the question was on the brightness of the bulbs.
Okay, thank you very much. I do get that. I don't know, Alota, if we are satisfied with the response. And then
No, it's okay, Mr. Mabi, because my concern was that we have 2 control variables in this point. We have the resistance being the same as well as the potential difference, even though we have.
Okay, I think the term happy.
Mhm.
We will go look into what that is saying, and then I think we will definitely get back to Elaine.
Ntate Mohapi.
Ma'am,
Yes, the resistance is controlled. The total resistance will change when, yes, the total resistance will change because now we have two resistance.
I can't find.
there is someone with an open mic. Can you please close your mic, ma'am? Matlahlela, we are on the floor. Eish,
Moetse.
I
I'm
just want
saying
to
that
find him.
the total resistance, yes, it will change after when the switch is open, of which that will also affect the current. But the potential difference because of the parallel connection will remain constant.
Yes.
So I think what I will do in the final memo, we'll just make examples and then we'll put magnitude so that they can see what is happening there.
That is what I wanted to suggest, that we put some ratios to show, or rather an example to show how we arrived at the answer. I think maybe we can also show in that example that we are going to put in the memo, ma'am, or the consistency of that response using a different formula like P squared to I squared R, ne? Or how will they, yeah, if it will be consistent even when we use P squared to V squared over R. I think it will be
for
very helpful.
1.8, we'll also write something down so that teachers can also go through that.
Yes, please. Yeah.
Okay.
No, I think colleagues, we are okay with that. I don't know. On that point, it will be responded to in the updated memo. We still have got a hand from Tabo. Tabo Raymond.
Yes, Minya. Am I audible, Minya?
Yes, you are audible, Minya. You can shoot.
Yes, Minya. I just wanted to maybe put some clarity there before I can make an example that I normally make to. First off, the examiner said ignore the internal resistance of the cell, meaning the external voltage is going to stay the same. So the power rating and the voltage rating on X and Y will stay the same. Hence, the brightness of X and Y will stay the same, will not be affected by the change in the total resistance of the circuit. So like in a classroom, we normally have classes whereby we have these lights that are connected in parallel. If one of the bulbs dies, the brightness does not increase just because one of the bulb died. It means X and Y, they are working independently in that regard because of the fact that internal
resistance.
Yes, internal resistance is ignored. So the power rating and the voltage rating on X, Y, and Z, or on X and Y, stays the same. Hence, the brightness will not be affected by opening switch S.
No, thank you very much, Mineria. Thank you.
I think he clarified it well. Yeah.
Yeah. Okay. There are no other questions I can see. Butipe, can you please explain 1.5, because test charge is placed on two, both charges, on two. Both charges will go to the right. I did not get it. All right. Butipe, can you please unmute and explain your question? Butipe Ofinze? I do not get it. Yes, do you get it that?
I can share, but how to more. I'm thinking maybe I understand what to understand what is happening.
Okay.
Yes, the question says two identical charges, which is plus Q and minus Q, are fixed along a straight line as shown in the diagram below. So now what is important in this question? Not all included the correct context, then you can deduct 1 mark and give the learner a 1 mark there. So meaning it's not a 2 or 0 question, but it has a part marking with an exception that the learner must have included all the underlined words. Okay, 3.2, it says draw a labeled free body diagram showing all the forces acting on the piano. So as I've indicated, colleagues, in this question, again, we are having the marking criteria. We are saying mark awarded for label and arrow, meaning for a learner to get a mark, they must indicate a label, and then they must also be having an arrow, and that arrow must have touched the dot there. And then it says, do not penalize for the length of the arrow since drawing is not to scale. So we don't penalize for any of the length of the arrows. Any other additional force or forces, the learner will get 3 out of 4. And then if everything correct but no arrows, the learner will get 3 out of 4. And then if forces or force do not make contact with the dot, then the learner will have to also get 3 out of 4. So colleagues, as we mark these free body diagrams, let's refer to these notes such that we don't disadvantage the learners. And then also it's very important that we are having acceptable labels. So the labels which will be acceptable, it will be if the learner, they refer to weight SW or capital letter FG or capital letter FW, or if the learner is saying F on piano, or if the learner writes weight or mg or 250 Newton, since it was given in the question, or gravitational force. And then for tension, the learner will get a mark if they are saying T or capital letter FT, or if the learner wrote tension or 300 Newton. And then for the friction, here we are expecting the learner to say a small letter F or capital letter F with a small letter F, or Fs, the static friction, since the object is not moving. And then, and also if the learner wrote 1, 2, 3 Newton, the value that was given for the friction. But I think there's a mistake there with FWs. Therefore, it is not supposed to be FW there. That was something that is put there by a mistake. And then for the normal, we'll give a mark if the letter gave a capital letter N, or Fn, or normal, or F normal, or just normal. So those are the acceptable labels for the free body diagram. So in our free body diagram, we are expecting the learner to draw the free body diagram with the forces not being resolved, especially the tension as well as the weight. So we want the learner to give the forces as they are. So meaning we'll be having our friction upward, then we're having our weight downwards toward the center of the F, and then tension there at an angle, and then also the normal will be perpendicular to the inclined plane, which was given in the question. Okay, that's how we'll get the 4 mark, meaning each and every force here will be allocated 1 mark, provided the learner drew the vector correctly and with a labeling. And then when we go to question 3.3, it says calculate at 3.3.1 angle theta. So here we want the learner to calculate angle theta. So how are we going to mark the question? First option, we are saying taking down the incline as positive. If the learner take down the incline as positive, I think the learner can put a positive here on this side and then a negative on the top side. Then the learner will see that on the first option, we're having F net is equals to MA, then we'll award 1 mark for any of the formulas there, either F net is equals to MA kappa weight parallel minus friction minus tension is equals to 0, or mg sin theta minus friction minus t with cos theta. They will get 1 mark for any of those formulas. And then for the correct substitution of 250 multiplied by 9.8 multiplied by sine 35, which is the calculation of the weight parallel, a learner will get 1 mark. That will be the second mark. And then for the whole substitution that is remaining, which is negative 1, 2, 3, 4, which is the friction minus 300 cos theta, the learner will get another mark. And then the other mark will be on 0, because if the learner understood that the object is not moving, then they will know that the object is not accelerating. So as a result, our acceleration there must be 0. Therefore, the whole of the left side, m multiplied by a, will be 0. And then they will get their angle as 55,19. And then that will get the last mark, meaning it's a mark on the formula, mark on calculation of the weight parallel, mark on the substitution of the friction and the component of the tension. That will be another mark, mark on the 0, and the last mark will be allocated on the correct value of the angle. And then second option, if the learner used up the incline as positive, again, they will get a mark for the formula, any of the formula. They will get a mark again for multiplying 250 by 9,8 sine theta, sine 35, which should be now negative because of the choice of the direction. That whole substitution is 1 mark. And then they will get a mark again for friction of 1, 2, 3, 4, and 300 cos theta. being positive, that whole substitution again will get 1 mark, and then 1 mark for the 0, 1 mark for the final answer as well. So that's how we will allocate the 5 mark for the question, the sub question 3.3.1. And then for 3.3.2, we are going to consider positive marking from 3.3.1, meaning the angle that the learner got there will now have to be substituted in 3.3.2. In this question, they are saying the learner must calculate the normal force. So it means for the learner to calculate the normal force, the learner will have now to consider the free body diagram and check that our normal will be balanced by the weight parallel, weight perpendicular, as well as the component of the tension, the vertical component of the tension. So I think there it was supposed to be weight perpendicular. I think it will be rectified in the final memo. There on the formula is supposed to be weight perpendicular. Therefore, it will be 250 multiply, or the learner will get the first mark for the formula, correct formula, and then second mark will be into the whole substitution, whereby they will have to multiply 250 by 9.8, cos of 35 minus 300, sine of 55.19, which is the angle that they got on 3.3.1. And then the third mark will be on the value of the normal, which is 1760.61. That where the third mark will be. And then the last mark will be on the direction, whereby the learner will have to say normal is perpendicular up the incline. So we'll give the last mark there on the direction of the normal force. Because we remember, colleagues, we are dealing with vectors. So the learner must indicate both the magnitude and the direction. And then for 3.3.3, it was say the learner must calculate the static frictional coefficient. So in this question, we will have positive marking from 3.3.2, meaning the value that the learner got for the normal, they will have to substitute it in this question as well. So where will the first mark be allocated? So for the learner, when they substitute into the maximum static frictional force equation, it must have that max. I think we indicated on the march that it's very important to include the max there, meaning copying the formula as it is from the formula sheet. That will be 1 mark on the formula. The second mark will be on the whole substitution into that question. And then the other mark, I think here it says 3, but on the question paper, it was saying 4, meaning we'll also try and rectify it, meaning the learner must get a mark on the 1, 2, 3, which is for the substitution of the friction. And then the learner also, they must get a mark on the right-hand side, whereby they multiply the coefficient by the normal that they got in 3.3.2. And then the last mark will be on the final answer, which is 0.7. And that the whole of that question will be 18 marks. Mr. Mahapi, anything from your side?
Thank you very much, Mr. Lekhooa. I see 2 hands, and there is a comment that the memo is not visible, but on my side, the memo is visible. I think it is the network of those people. Just check your network, colleagues. Matula Marumo and Zema Khatebe. The memo is still visible from my side. So we'll take the 2 hands on question number 3. Before Ntatenzie, can I please take Lincoln, is it?
Yes, good afternoon, colleagues.
Good afternoon.
Afternoon.
Okay, at 3.3.2, can you also accept when the learners are using the formula F naught is equals to MA?
Come again?
Can you also accept at 3.3.2 when learners are saying F net is equals to MA, and then they say Fn plus Fa plus Fg is equals to MA, then they're gonna equate that MA to 0?
No, I think we can accept as well.
Okay.
Thank you.
And Then the last one is for that one at 3.3.2, that when I checked, most of the learners, they don't include that perpendicular up the incline because the normal force, it is perpendicular to the surface as well. That can we maybe look at it? I don't know. That's my plea because I see that most of the learners are not including that part.
Okay, no, I think we are noting it, but for future purposes, it's very important that we teach our learners that if it's a vector, they must give the magnitude and the direction. But we will look into it. And then I think in the final memo, we have made a conclusion on it.
Noted. Thank you, sir.
Thank you.
Thank you very much. There is no other hand. Tatensia, you can come in before Emma.
Okay.
Mhm.
Yeah. Question 3.2, Ntate Lekhooa. On the friction, that FW there is correct. It is just for Africans for framing. So that FW, it is actually for the Africans version. So it is fine there. Thank you.
Oh, it is fine, Meneer. Okay, thank you.
Yeah.
No, thank you very much. Mema Lastella.
I'm on 3.3.2 on the direction of the normal force.
Mhm.
If we ask a question and we do not say calculate the magnitude, it means learners know that a force is a vector. So the direction of that force must be indicated. So in this case, the normal force, it acts perpendicular to the surface. So we're not going to change it because the question did not ask for the magnitude. It will remain as is. Then we request teachers to go back and teach learners that the normal force as they draw it on the free body diagram, then they can also put that direction in the calculation. Thank you.
All right, no, thank you very much. I do not see any other hand in the Lekhooa. Maybe we can then move on to question number 4.
Okay, no, thank you very much, and that I'm happy. Okay, question 4, still on Newton's laws. Colleagues, we did indicate that as we teach in our classes, let's emphasize graphs as well. I think I also indicated in the assessment framework that there will be graphs. So let's modify our teaching that whenever we are teaching these physics concepts, we also integrate graphs into our teaching. Okay, in this question, it says 2 blocks of masses 12 kg and m kg are joined by an inextensible string and is moving along a horizontal surface. A force of 100 Newton is applied to mkg block. So come on, Soma, we are having that 100 Newton being applied in our mkg block. Now it says the velocity versus time graph for the movement of the mkg block is shown below. So very important that whenever you are given a graph, understand what the graph is for. And here the examiner indicates clearly that the graph is for the mkg block. I think that is a very important point that we need to emphasize. If we can look at the graph, we can see that our graph started at 0, and then between 0 and 7, our object mkg block is accelerating from 0 to 7, and then from 7 to 10. Now the object is no longer accelerating because the velocity is no longer changing. So I think as we also do this graph, let us also take our learners into the interpretation of the graph, or what is happening into the graph. I think it's very, very important. Meaning our object is accelerating from 0 to 7. Now, in the first questions, which is 4.1, it says state Newton's second law of motion inwards. There also it's very important to remember the marking criteria that if any of the underlined keywords or phrases in the correct context is omitted, we will deduct 1 mark, meaning it's not a 2 or 1 question, 2 or 0 question, but we consider whether the learner has included the keywords or phrases in the correct context. So the learner is expected to say, when a resultant or a net force acts on an object, the object will accelerate in the direction of the force at an acceleration directly proportional to the force and inversely proportional to the mass of the object. And then we'll give 2 marks for that. But provided the learner did not include all the underlined words in the correct context, we'll deduct minus 1. And then in 4.2, it says, show by means of a calculation that the acceleration of the MKG block for the first 7 seconds is 3.14 meters per second squared. So here the expectation was that in option 1, the learner can use the gradient. So colleagues, like we indicated in the first, in term 1, that if the learner, they are using a gradient, they must interpret the gradient in terms of the physics quantities, physical quantities, to say acceleration. I mean, for example, gradient is equal to acceleration. That will be very important. Hence, we are giving a 1 mark there. And then they will further say gradient is equal to change in V over change in time, substitution of the 22 minus 0, and then also 7 minus 0 will give another mark there. And then that's how we'll allocate the 2 mark if the learner used gradient to calculate or prove their acceleration. And then option 2, the learner can use equations of motion. And then when they use the equations of motion, V final will be equal to 22, V initial will be 0, and then they will say A multiplied by 7, meaning we'll give a mark for the formula, mark for the entire substitution, and then that's how we'll allocate the 2 mark for that question, because we were proving that acceleration is equal to 3.14 meters per second squared. And then for the 12 kg and the MKG blocks experience frictional forces of 6 Newton and 9 Newton respectively. So now we are told that the 12 kg and the MKG blocks, they experience frictional forces of 6 Newton and 9 Newton respectively. So at 4.3, the examiner says calculate the magnitude of the tension in the stream for 4.3.1. So in order for the learner to be able to calculate that particular tension, 1 will give a mark for any of the formulas. If the learner said F net is equals to MA, or T minus FB is equals to MA, will give another mark, because why? We can't use the first block, which is the MKG block. We'll have to work with the second block, which is the 12 kg block, because we'll be having 2 unknowns if we can work with the MKG block. So we'll give 1 mark for the formula, and then give another mark for substitution of -6, and then into the equation. And then we'll also give another mark for substitution into the right-hand side, where the learner multiplied the mass with the acceleration. We'll give another mark there. That will be the 3rd mark. And then the last mark will be the magnitude of the tension as well as the direction. We'll allocate it 1 mark. So that's how we'll allocate the 4 mark in that question. But it's very important to take note that if left was used as positive, we'll give maximum of 3 out of 4 for this particular question. So the learner, they are supposed to use left as negative, meaning if the learner there wrote or substituted that 6 as positive, then it means we'll have now to allocate 3 out of 4 for the learner. So it's very important to take note of that statement that is put there at the bottom. And then for the last question in this question, which is sub-question 4.3.2, it says calculate mass M. So we will now want the value of the unknown mass of the second block. Now, to calculate that, we are saying that you should consider that there's positive marking from 4.3.1, meaning the value of the tension that the learner used in 4.3.1, they will have to use it in order for them to avoid having 2 unknowns, because now we know the value of the tension, as we know that the tension that is acting on the 12 kg block is equal to the tension that is acting on the MKG block, but they're just in the opposite direction. And in this question, or these questions, we are focusing at 0 to 7 because at 7 to 10, you remember that our object is no longer accelerating. So for this question, how are we going to allocate marks for this question? We'll allocate our marks in terms, we will not give any mark on the formula, but we'll give a mark on 100 minus 43.68 minus 9, which is our substitution of the force applied on the MKG block, the tension calculated on 4.3.1, and the friction, the whole substitution will be 1 mark. And then the second mark will be now where the learner substitute the MKG, which is what we are looking for, and the acceleration that they were given of 3.1.4. And then the whole of the right and side substitution will be another mark. And then the last mark will be on the final answer of 15.07 kg. And that will be 3 marks in that question. And then the whole of question 4 will be 11 marks. Thank you, Meneer. I don't know if you are having anything from yours.
I do have something, Meneer, but before I get to those questions, Mema Lasel, I see your hand up.
Yes, and that I wanted us to go back to 4.2. So for 4.2, because we asked the learners to prove that acceleration equals to 3. As that gradient equals to acceleration. So I suggest that we move that mark to the substitution of the numerator and the denominator, which will give us 1, 1.
Okay, Memalahle, we will consider that, but we did indicate much to say if the learners they are working with gradient, they must tell us what, in terms of the physical quantities, that gradient, which physical quantity it is, but we will look into it, Memalahle.
Yeah, I agree with you that I can, but saying we know they're not going to write it down unless if they are asked to indicate the gradient. Yes.
Okay. That I'm happy from your side.
And that will also go for option 2. If we do not give for the formula, then it means for option number 2. If they use that equation of motion, then the mark will be on the substitutions. And
okay, yes, meaning on the left-hand side substitution.
In the right-hand side, yes.
Yes.
Okay. Now, that is for consistency. That's that on question 4.2. And then for 3.1, Alota, the right is not needed there as the question is looking for magnitude. So if the learner does not write right and gives only the magnitude, I think we will accept Meneer. Eh?
Yeah, we'll accept because I think we indicated already, even the allocation, there is not on the magnitude and the direction, it's just 1 mark for that magnitude. Correct, that final answer, meaning it's for the magnitude technical.
Or which means that we'll put that right, that direction in bracket.
Yeah, in
so
bracket.
that it is clear to everyone.
Yeah.
Okay.
Yeah.
No, thank you very much. Besides that, I do not have anything. I think we can then move on. Okay, Mr. Maile, I fail to understand why formula of the gradient must be ignored. I think it is ignored in many instances because it is not given in the formula sheet. So we also want to avoid a situation where now a learner will write change in X or change in Y over change in X, which is technically correct, but we will not accept. Ne? So I think that is how we'll be moving forward with this thing.
Okay. No, thank you, Mr. Happy.
Thank you very much. And then I saw a hand of Encrate, but the hand is now down. Mr. Tekiso?
All right, thank you very much. Ntate Mohapi, I'm just checking there on that note on 431. And then it specifically says if left is taken as positive, then they shouldn't get the maximum marks. But I wonder, what if then you so decide that you put the negative for that acceleration as well? I'm just checking there.
Okay. Or let's say the learner used +6, but they put a negative.
Yes, let's say as it is written there on the substitution, maybe they say minus t plus 6 is equals to 12 into
Yes.
negative
No,
3 and
I think that one we can accept that.
Okay, very much.
Thank you. That am happy?
No, I was saying maybe you can repeat what you just said. What can we accept?
Oh, that the Tekisho was saying if the learner used negative t plus 6 is equals to 12, but they say minus 3.14 instead of positive. Now, can we accept that? Because of we are saying if the learner says left was positive, they must get 3 out of 4. So I was saying in that instance, I think we can accept that.
Oh, okay. No, thank you very much. Mr. Maile.
Okay, only be because in the previous term or previous assessment of grade 11, so we're discussing the very same thing, that the formula must be written and must be awarded a mark, provided that it is written in the context of the scenario as in quantities or variables. So I do not understand the suggestion of why that mark must be moved to substitution rather than the formula.
Yes, and you remember the discussion we had. So to avoid such discussions, we then resolved, or how about then we move that mark away from the formula, especially when a learner is not asked to prove as to whether the what does the gradient represent in such instances. Then we rather then go to the substitutions mania. Because now a learner is not wrong to say changing y over changing x is gradient. But then we do not want to give a mark for that. We rather then say, let us mark on the substitutions. That is basically what we have come to agree on here.
Okay, no, thank you.
Yes. So if a learner is expected gradient represent maybe. In that instance, then we'll then expect the learner to show through the formula, the waking up to whatever physical property that they will come to. But in this instance, then we'll not give. You can imagine if a learner then writes delta y over delta x, that learner is not technically wrong, but we can't give it. That is what we are trying to avoid here. Mr. Nzie.
Yeah, I think that you covered it. And at the same time, colleagues must also realize that it is not always or given that a formula will always get a mark. So for this case, if the learner just calculate the gradient and then say nothing about what it is equaling to, then we'll end up not knowing actually what is it that he was calculating. Hence, that mark of gradient being equal to the acceleration, it is rightfully placed there. I think that is the essence of it. That.
Okay, Mr. Nzie. No, thank you very much. And Tate Tekiso?
Yes, thank you, Hape. Ntati. Still on that 4.2. Now, if we are gonna go with allocating a mark for 22 minus 0, 1, and then I would like to suggest, unless if we are not agreeing, that the scalar quantity underneath be accepted as a 7 only, if there are letters who have done so. Because delta t usually it's not most of the time that they will be showing a 0. So I imagine if they, for example, say, okay, acceleration is 22 minus 0 over 7, and then they will get the answer of that. So I was suggesting that for that delta t that we accept as 7 only, if that is the case.
I know what Mema Lachela is going to say, but let me allow her to say it. Mema Lachela?
Or let me not say it, then say it in that.
Say it to me.
That we are talking to change here, so let them show the change. That is 7 minus 0. So we're not going to award a mark for 7 only. It's supposed to be 7 minus 0. And then, colleagues, if you check the 12 regarding the formula, all the formulae that are not given in the data sheet, we should not penalize the learners, especially for this one for gradient. But it is also important for us to teach the learners, if you are given the graph, use the physical quantities that are in the graph. So we're not going to award a mark for the formula, but we'll award the mark for the substitution, as long as the learner shows that I understand that with the graph that I'm given, the gradient is acceleration. Thank you.
No, thank you very much, Mme. 3.3.2. So Andrea is taking us back, Mini Raskis. Can we just go up a bit to 3.3.2? Should the symbol not, we responded to that, Andrea. It will be corrected in the updated memo. It should be perpendicular there, yes. Okay, no, thank you very much, Minir. We do not have any other question. We can move on to question 5.
Okay, thank you very much, Minir. Question 5, it's a question from electrostatics, and it reads as follows. Two identical spherical balls A and B are suspended from a ceiling by an insulated, light, inextensible strings of equal length. The balls each have a mass of 12 grams and carry identical charges. So we are given the diagram representing what is said in the statement, whereby we are having a ceiling and the two balls which are pulled. Distance between them is 100 centimeter, and then the angle there is 9 degrees on either side. So I think it's very important. From the statement, we can see that our mass is in grams and our distance is in centimeters. I also indicated in the examination assessment framework that the learners must know how to convert. They should expect something like that. Now it says the balls are at rest with a distance of 10 centimeters between their centers. Each stream makes an angle of 9 degrees with the vertical as shown in the diagram. And then 5.1, it says state Coulomb's law in weights. Even here, colleagues, it's not a 2 or 0. We are expecting that you follow the marking criteria. If any of the underlined keywords or phrases in the correct context is omitted, deduct 1 mark. So meaning the learner is expected, according to examination guideline, to say the magnitude of the electrostatic force exerted by 1 point charge on another point charge is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. So if any of the weight is omitted there, you deduct -1. And then for 5.2, it says, evaluate whether the following statement is true or false and explain your answer. The statement says, the tension in each string is equal to the electrostatic force acting on each ball. So here the learner is expected to give their answer as false, that the tension in each string is not equal to the electrostatic force on each ball. Why? Because the horizontal components of the tension in each string are equal. So meaning the horizontal components of the tension, as you resolve from either side, they will be equal because they are at the same length, and then they are being pulled by the same strings of equal length. So that is why we are saying that the horizontal component of the tension in string will be equal, because the electrostatic force on the balls are equal in magnitude. So meaning we'll give a 1 mark. So it's part marking whereby we'll give a mark for the horizontal component of the tension in each string equal 1 mark for that, and then also the other mark will be where they are saying the electrostatic forces on the balls are equal in magnitude. That's how we will allocate the 2 marks for that particular question, 5.2. And then 5.3, it says, draw a labeled closed vector diagram for ball A. So now the focus now is on ball A. So how are we going to allocate the mark for the drawn closed vector diagram? One, it's very important to consider the marking criteria. In the marking criteria, we are saying correct vector with labelings. So colleagues, we need to teach our learners, as I've indicated earlier, to say we give a mark if there's a correct vector drawn with an arrow and the correct labeling. So for all the forces, 3 of the forces will allocate 1 mark for each force if it's drawn correctly and there is a labeling. And then the last mark will be on the closed vector diagram. So colleagues, as we mark and put our ticks, I think it's very important that you mark the learners looking at the marking criteria, because we'll find that when you get to schools, a learner has drawn a closed vector, but the teacher did not give a mark on that. So it's very important to consider the marking criteria. And then the acceptable labelings or labels will be W, and then capital letter G, and then FW, weight, mg, gravitational force. Those will be the acceptable labelings for the weight. And then for tension, we'll take capital letter T, and then capital letter F with T, and then tension. And then for the electrostatic force, we'll take Fe, electrostatic force, as the correct labelings for the electrostatic force. That will be 5.3. And then in 5.4, it says calculate the magnitude of the 5.4.1 tension acting on ball A. So now, as we said, the learner must draw a vector, a closed vector diagram for ball A. Our focus is on A, even here with calculation of the tension. I think the learner will make use of the diagram that they've drew, and then to calculate the tension, the learner will say T cos theta is equals to Fg. Then for that particular formula, will not give a mark there, but the mark will give it when they say T cos 9 degrees. Why? Because the learner can use cos 9 degrees or 81. Therefore, that's why we give the first mark there. And then the second mark will be on the correct substitution on the right for calculation of the weight with correct conversion, to say when you convert 12 gram, now you will have 0.012 multiplied by 9.8, and then we'll give the second mark there, and then the another mark will be on the final answer for option 1. And then for option 2, that's where now the learner will be using a sine instead of cos, but if they use sine, they must use an angle of 81. So it means the learner must be able to use the trig ratio interchangeably with the correct angles. Therefore, we'll give 1 mark if they say T sine 81. That's where the first mark will be allocated on the second option. And then the second mark again will be given on 0.012 multiplied by 9.8. And then the last mark will be on the final answer. And then we'll go to the last question, which is 5.4.2. So in this question, we are considering positive marking from 5.4.1, where we are saying the learner must calculate the magnitude of the charge on each ball. Now, to calculate the magnitude on charge on each ball, we'll say Fe is equals to T sine theta for the first option, and then we'll not give a mark there, but we'll give a mark where the learners, they are substituting, meaning that 0.119, it's a value that will be coming from 5.4.1. Therefore, if the learner substituted the value that they got there, they will get the 1 mark for that correct substitution with the correct angle of 9 degrees if they are working with the trig ratio sign. I think here, because we are talking about T sine theta, yes, I think sine theta, it was indicated as S9 there, yes, okay. If the learner wrote F is equals to KQ1, Q2 over R squared, they will get a mark there. And then another mark will be on the substitution of the force that they will have calculated above of 0.0186. And then the second mark will be on the substitution on the right-hand side, where the learner will say 9 multiplied by 10 to the power of 9 q squared, because our charges are identical. And then the last mark will be on the final answer of 1.44 multiplied by 10 to the negative 7 coulomb. And then on the second option, again, we'll give a mark where the learner is saying 0.119 sine of 81. And then I think there, with option 1 and option 2, I think there must be a change of the trig ratios. And then again, the learner will get 0.0186. Therefore, we don't give a mark there, but we give the mark again on Coulomb's law, which is F is equals to KQ1, Q2 over R squared. And then if they substitute the answer you got above of 0.0186, a mark will be given there. And then also another mark will be on the substitution on the right-hand side when they say 9 multiplied by 10 times 10 to the power of 9 q squared divided by 0.1 squared, and then their final answer is 1.44 times 10 to the power 10 to the negative 7. I think that will be the end of question 5. That I'm happy, anything from your side, and the total of the question will be 70.
Thank you very much, Ndate Lekhooa. I do not see any question and we do not have any hands. I think question 5 was clear to all colleagues. Maybe we can then move on to question number 6. Yeah, okay. No hands, Menier. We can move on.
Okay. No, thank you very much, Menier. Question 6. Question 6 is from electromagnetism. I think I did indicate earlier that in this question, there was a 2 mark that was allocated in the statement, of which it was not supposed to be there. So this question is supposed to be 17 marks instead of 19 as it was indicated in the question paper. So the question reads as follows. A bar magnet is moving towards a solenoid that has a galvanometer connected to it. And then 6.11, it says, name the rule that is used to determine the direction of the induced current. That, can you please mute the person that is making noise? Okay, thank you very much. And then 6.11, it says, name the rule that is used to determine the direction of the induced current. Colleagues, we know that for us to get the direction of the induced current in that question, we'll have to use the right-hand rule. And then that will be 1 mark for the learner saying is the right-hand rule that must be used there. And then 6.12, what is the polarity of the induced magnetic field as at point A? So for the magnitude, for the polarity of the magnetic field at point A, the learner is expected to say, as the magnet is approaching the solenoid, or I mean the galvanometer, yes, the solenoid that is connected to the galvanometer, on that side A, enough pole will be induced there. I think that's why we allocated 2 marks there. So the learner will have to know that the polarity there will be north as the magnet moves towards, meaning as the magnet is moving away, there it was supposed to be south there. I think I also explained it when we were doing the framework. And then the magnet enters the solenoid at point A and moves through the solenoid exiting at point B. And then the learner is expected there to say 6.13, what will happen to the needle of the galvanometer as the magnet exits the solenoid at point B? Explain your answer. So it's 3 marks. The first thing that the learner will have to say will say the needle will deflect in the opposite direction, meaning as the magnet is exiting outside the solenoid, the will change Hence, we are saying that it will deflect in the opposite direction. That's the first mark where we'll give it. And then the second mark will be placed when the learner explained that the solenoid will create a north pole at B to attract the departing south pole. So it means the second mark will be given if the learner will say the solenoid will create a north pole at B to attract the departing south pole, because you remember as it enters with north, but as it exits with south. Hence, we had to indicate that, meaning on B side, there will be induced a north pole as the magnet is exiting. So that's where we'll give another mark. And then the last mark will be when the learner says this results in a reversal of the direction of the induced current. When the learner indicates that this will result in the reversal of the direction of the induced current, therefore that's where we'll award the third mark. So that's how we'll mark this question. And then 6.14, it says name 3 ways in which the induced current can be decreased. I think what is important there, it's for the learner to note that we want the induced current to decrease. So one, the learner, they will have to say in that question, it will decrease the speed or the induced current will be decreased by decreasing the speed at which the magnet moves. That's number one. Number two, use a weaker magnet or decrease the magnetic field strength. And then lastly, decrease the number of turns or loops in the solenoid. So technically, by decreasing the speed, the strength of the magnet and the turns, then that will result in the induced current being decreased. That's how we'll award the 3 mark in that 6.14. And then 6.2, it says a solenoid of length 5 centimeter and 50 turns enters a uniform magnetic field at speed of 1 centimeter per second. I think there is very important to say that 5 centimeter per second. So it means the magnet field strength of 0.6 T. Now, in the first question, the learners are expected now to state Faraday's law of electromagnetic induction in width at 6.21. So for that question, we allocated 2 marks there. So this question will be a 2 or 0, meaning why? Because the learner is expected to state it as it is, meaning the magnitude of the induced EMF across the ends of a conductor is directly proportional to the rate of change in the magnetic flux linkage with the conductor. So here we are not having part marking. I think, colleagues, it's very important that you note we indicated there 2 or 0, because I know we'll get to schools and then teachers have given learners 1 there, but we indicated that is a 2 or 0. And then on 6.22, it says, how long will it take the coil to completely move through the magnetic field? Meaning, how long will it take the magnet to completely cover that particular area given of the magnetic field? So we are saying that 25 seconds. Why 25 seconds? Because we are considering the area where now the magnetic field will be, or the square coil will be passing, meaning will be passing that entire area. Hence, we're giving our answer there as 25 seconds. So we are considering the area because remember we said 1 centimeter per second there. So it means if it's 1 centimeter per second and it's moving in that entire area, it will actually cover 25 seconds. That's how long it will take. And then for 6.2.3, it says calculate the magnitude of the induced EMF. So now to calculate the magnitude of the induced EMF, we will consider positive marking from 6.2.2, meaning the answer that the learner got in 6.2.2, they have to use in this question. So now, firstly, the learner will have to calculate the magnetic flux linkage, whereby they will have to say B A cos theta, will not give a mark there, but we give a mark on the substitution when they substitute 0.6 that they are given in the statement, 0.05 multiplied by 0.05, which is the area cos of 0, and then the answer will be 0.0015. Will not give a mark on the answer there, but will give a mark on the formula when they write Faraday law equation. 1 mark will be given there for the second mark, and then the third mark will be on substitution of 50 tenths, and then the last mark, no, the fourth mark will be on 0 minus 0.0015, which is a value they got above, divide by 25 that they got for the time that they calculated in 6.2.2, and 0.003 volt, or you can write it as 3 multiplied by 10 to the negative 3 volt, and then that will be the last mark. The whole of question 7 will be 17 mark, because of there was a mistake in the question paper with allocation of marks on the statement. Thank you, Ndate Mohapi. Anything from your side, Menia?
Yes, we have two. Let me recognize Ike.
Hello. I would just like to ask some clarification on the 25 seconds, because I have it as an area of 20 centimeters at 20 seconds.
Okay, let me just look into it. I think we will look into it and then just get back to you with regards to that. Or I don't know if Mema Lasela, can you help there?
I will get back to you. I'm looking at it.
Okay, I'm also looking at it.
All right.
So come again, that might be just for surety purpose that I got the next question right. Me was asking on the 25.
Yes.
Okay.
Yeah, but that will affect 6.2.3 as well, because I will put 20 in delta T.
So you are saying the correct answer is
20, because it's 1 centimeter a second and an area of 20 cent, or a length of 20 centimeters. So 20 seconds.
okay.
I failed to see the 25 seconds.
Okay. Noted,
Yeah.
Sorry, can I
Yes.
come in there, please?
Yes, please.
I think if you look at the solenoid, the length of 5 centimeters, it will take the front part of that square will take 20 seconds to reach the other side of the magnetic field, but then the rest of the square is 5 centimeters long. So for that, another 5 seconds, part of it will still be in that magnetic field. So for it to totally clear the magnetic field, because of its own surface length of 5 centimeters, your total distance is actually, for it to clear the field, 25 centimeters, and that will then take 25 seconds for it to go through it.
Okay.
All right. Thank you very much. Ike, does it make sense?
Hear it. I'm also just quickly thinking about it, because, okay, I agree. The moment the solenoid touches the area, or not touches it, but as soon as it starts moving in, I agree there will be magnetic flux linkage, and then or there will be magnetic flux, and then there will be magnetic flux linkage as it moves through. So yes, but I think we do just need to make 100% sure of that.
Okay. No, thank you very much. Then there is a question from, your hand is still up. Oh, no, thank you very much. Question number 6.1.3. Can I accept if a learner did not indicate North Pole at B, but said the magnetic field forms that opposes this change?
But I think we did underline it in the demo happy, so they must indicate, meaning it did not indicate, we will not accept.
Okay.
Because we even underlined it that it's key for us.
Okay. No, thank you very much. Besides
Then I'm happy.
Yes, Meneer.
Oh, for a moment I lost you, but you are back now.
Okay. Now I was saying we do not have any other question. We can then move on to question 7.
Okay, question 7.
Okay.
Okay, thank you, Meneer. Question 7 will be electric circuit. It reads as follows. In the circuit diagram below, a battery with an EMF of 12 volt is connected to 4 resistors, a switch, an ammeter, a high resistant voltmeter, and connecting wires. The resistance of the connecting wires, ammeter, and battery are negligible. Then the switch S is open. So meaning at the beginning, we are starting with an open switch. And then if the switch is open, as given in the diagram, there's no any flow of current in the circuit. But at 7.1, they say what is the reading on the voltmeter when switch S is open. So because of I indicated that as a result of us not any flow of current, then it means the voltmeter reading will read 0 volt, meaning there will not be any value there for voltmeter because there's no current flow, meaning that resistor R will not be effective. Then they are saying now switch S is now closed and the reading on the voltmeter is 4 volt. So now at 7.2, what is meant by 4 volt reading on the voltmeter? So here we are expecting the learner to say 4 volt means that 4 joules of energy is dissipated per coulomb of charge. So meaning we'll award a mark, 2 mark in such a way that 1 mark will go to the 4 joules of energy is dissipated if the learner indicated that 4 joule of energy will be dissipated, and then the last mark will go to per coulomb of charge. So I think that is it's very, very important. So that's what that 4 volt means. And then at 7.31, they say calculate the effective resistance of the parallel combination. So here we want the learner to calculate the effective resistance of the parallel combination. So how are we going to award mark in this question? Number 1, we'll award the first mark for the learner writing the formula for the parallel connection correctly. That's where the 1 mark will go. And then the second mark will go to the substitution if the learner realized that on the first branch we're only having 4 because after we've closed, our current will come and then it will split. When it gets there at the junction, the other current will go to the 4 ohm, but the other current will go to the 4 ohm plus the other 4 ohm, meaning those 2 resistors in that particular branch are in series with one another. So if the learner says 4 plus 4, then they will get a mark there. If they're saying 1 over 4 plus 4 to show that in that branch we are having 2 resistors, meaning we are having series within the parallel. And then that's where we'll allocate the second mark. The third mark will go to the substitution of the last resistor, which is in parallel with the 2 other resistors. That's where we'll allocate the other mark. And then the final mark will be on the final answer for the parallel connection calculation value of 2.67. So that's how we'll allocate the 4 mark in that question 7.31. And then 7.32 is the learner must calculate the reading on the ammeter. So since now the switch is closed, it means there will be a flow of current in the circuit. Now to calculate the reading on the ammeter, 1 will consider positive marking from 7.31. The learner 1, they will get for the Ohm's law, RP is equals to VP over I. That's where the first mark will be. And then the second mark will be on the entire substitution, meaning as we've indicated, is positive marking from 7.1. If the learner used 2.67 or the answer that they got in 7.31 for the parallel connection, because here we are focusing on the parallel connection as the current that passes in the parallel connection and the ammeter there is the same. So hence we were using the parallel connection. Therefore, when they say 8, because for the fact that we know in the series circuit that the voltmeter is 4 that we are given, we'll minus that 4 from the 12 and get 8 for the parallel, using it together with that resistance that will have been calculated in 7.31. Therefore, we'll get our current as 3. So we'll allocate the second mark on the entire substitution, and then the last mark will be on the final answer. That's how we'll allocate the 3 mark in 7.3.2. And then 7.3.3, the learner is asked to calculate the resistance of the unknown resistor R. So for the learner to get the resistance of the unknown resistor R, that is where we are allocating that 1 mark, which was allocated incorrectly as the 2 mark in electromagnetism. So the first mark will be coming here, meaning we'll give again the first mark for Ohm's law, and then second mark will go to the substitution of 4 divided by 3, whereby the 4 is the voltage that we were given in the statement, and then the 3 is the current that is passing on the ammeter, which will be passing at RS3. Therefore, the last mark will give to the final answer of 1.33. That's where we'll give the final mark. And then the whole sub-question 7.33 will be 3 mark. And then 7.34, learners were asked to calculate the total power dissipated by the battery. So for the learner to calculate this power dissipated by the battery, we'll consider positive marking from 7.32 and 7.33, meaning the value that they got for the parallel connection, and no, the value that they got for the parallel ammeter reading of the current, as well as the resistance of R. So meaning in option 1, the learner can use the total voltage provided by the battery multiplied by the total current, then they will get their power as 36, meaning 1 mark for formula, 1 mark substitution, 1 mark final answer. And then in the second option, the learner can start first by calculating or showing calculation for the series combining with the parallel, meaning 1.33 for series, which is the value of the resistor, they calculated resistor which was unknown, plus the total resistance of the parallel connection. Now when it's 1 resistor replacing all the 3 resistors, then the total resistance will be 4, and then with the current of 3. Then if the learner substitute into this formula, P is equals to I squared R, they will substitute 3 for the total current of the circuit, and then 4 for the total resistance, and then they will still get 36, meaning we'll award 1 mark for formula, 1 mark for substitution, and 1 mark for the final answer. So meaning we are putting our ticks on this formula, last formula of calculating power, but not on the calculating the total resistance. And then on option 3, again, the learner can start by calculating total resistance by using R series plus R parallel, which is 1.33 plus 2.67, and then they will get 4 again here, but they will not substitute into the equation I squared R, but rather in the equation P is equals to V squared over R. Then they will substitute 12 as their value for the voltage provided by the battery, and then 4 for now the total resistance provided by the circuit, and then 36 will be the final answer. So we'll give 1 mark for the formula, substitution, and answer. And that whole question will be 3 mark. And then for 7.35, here the learner is asked to calculate the cost of operating for the circuit for 5 hours. If this circuit was now to be operated for 5 hours, because we know, colleagues, as much as that is a circuit diagram given, but that circuit can be in any of the devices or in the house or whatsoever. So if that circuit is operated for 5 hours and the cost, the tariff, maybe for the municipal or ESCOM, it's 3.20 per kilowatt hour, then it means for the learner to calculate cost, 1, they will have, we are saying there's positive marking for 7.34, and then the power that they got for the power dissipated by the battery, that power of 36, firstly, the learner will have to convert it into kilowatt, because now they get it there as watt. So for that conversion, we give 1 mark there, colleagues, 0.03. See, that is the first mark. And then they multiply it by the time, as well as multiply it by the amount for kilowatt hour given by the municipal. Then that whole substitution, meaning in this substitution, we award 1 mark for the conversion, 1 mark will be for multiplying by 5 and 3.20, and then the last mark will be for 0.58, which is the final answer. So colleagues, if you can check in the question paper, this question was allocated 2 mark. So it was supposed to be 3 for calculating cost. Hence, the marks are divided as 0.036, first mark there, and then second mark for 5 multiplied by 3.20, and then the last mark will be on the final answer, and then the whole of that 7.35 will be 3 mark. And then 7.41, it says resistor R is now removed. So we are removing that resistor in parallel. It says, how will the following in the circuit be affected? Write down, increase, decrease, or remain the same. Then for 7.41, it says the reading on the ammeter. So it means if we are removing that resistor, technically we are affecting the total resistance of the circuit. Therefore, the reading on the ammeter now will have to increase, because we'd have decreased the resistance, because we'd have now having our resistors only in parallel. Then the answer there will be increased with 1 mark. And then 7.42, it says calculate the reading on the EMF of the battery. How is it going to be affected? So we've done nothing to the battery. The battery, it's still offering 12. So it means as a result, the EMF will not be affected by us removing an external resistor. Therefore, the answer there will be remaining the same. So the whole of question 7 will be 21 mark, which initially was 19. Why 21? Because 1 mark was put there on cost for the conversion, and then the other mark was put into question 7.33 on the formula. Therefore, the whole question will be 21 mark. That is where that 2 mark, which was wrongly allocated in the statement, is added into this question 7. That am happy. Anything from your side?
No, thank you very much, Lekhooa. Yes, I have about, I think 3 on the chat, nothing on the hands. So let me go through the questions on the chat. Alexa asks about question 6.2.3. Can we go up a bit, Minier?
6.2.3.
And then they say, is the final flux not 0.0015 and the initial 0? Because it starts outside and enters the field. I know it does, yeah. So Alexa is asking, have we not swapped the 2?
Okay, like we indicated that we will look into this one, and then it will be updated into the final memo.
Okay, thank you very much. And then we have another question in the chat, 7.3.1. Maybe we can go just down.
3.1, yes.
Yes, and then can we mark 1/8 there on that branch? R1.
Yes,
if the
we can
learner
mark
just
it.
writes 1/8, can we mark it?
Yes, we can mark it, because it means that the learner understand that the 2 resistors will combine and form 1 resistor that replaces the 2, which is 8. So it's still correct, Mania.
Okay, thank you very much. 7.2.3. Yeah, without subscripts, if a learner just writes R is equals to V/I, can we accept that without the subscripts?
No, we can accept, Mania. I think it's just for the understanding, especially during teaching. Yeah, but we accept it's still Ohm's law.
Yeah, no, thank you very much. Those are the only questions that I have, Minier. I do not see any other hand. Maybe we can then move on.
To question 8.
Yeah, to question 8, yeah.
Okay, no, I think one of the what is important for the colleagues note that the 2 mark that was wrongly allocated in the statement, that is where now it is allocated in this question, that 2 mark. such that at the end of the day, our question paper is still 150. Okay. Question 8. A group of learners conduct an experiment to determine the EMF and the internal resistance of a battery by setting up the circuit as shown in the diagram below. The potential difference of on the voltmeter for different current streams in the circuit is measured. So we are given a diagram there. Then the results obtained are shown in the graph below. So in this question, colleagues, we are given a graph. Learners need to interpret what is happening to the graph. I think the question of the gradient comes in again, whereby the learners must know what the gradient represent in this question or in this graph, and then use the correct physical quantities that are used in the graph to calculate their gradient, not delta x and delta y. And then how are we going to award marks in this question? One, if the learner says gradient is equals to R, which is equals to change in V over change in I, we are giving another mark there again here for the gradient for the learner, indicating that the gradient represents R, which is the internal resistance. And then substitution of 10 minus 0, 1 minus 6, meaning the learner will have to go, because 6, even though it's on the x-axis, it's still a point on the straight line given there. So the learner can use that point and actually use also the coordinate that is given there of 10 of 1 is to 10 to calculate the gradient, and then they will get the gradient as minus 2 to show that is the internal resistance. So we give a mark on the formula there, delta V over I, mark on the entire substitution there. And then the other mark, it's when the learner now uses different coordinates, meaning initially the learner used the coordinate 10 minus 0 and 1 is to 6. But now if the learner uses the coordinate x is to 0, that unknown value that we don't know on the y-axis, and the 10, which is a line, a collinear point on the straight line. Therefore, also using the gradient, because the gradient will be the same since this is a straight line. So all the points in the line you can use to calculate your gradient, meaning you have to calculate the gradient there. The value that you get, you will substitute again here, calculating the gradient with different coordinates. The substitution of -2 and now new points x and 0 with 10 and 1, then that's where the second mark will be, meaning the first mark will be on the formula, on the first calculation of the gradient, second mark on the substitution, third mark on the substitution of the second calculation of the gradient, and then the last mark will be on the final answer if they get it as 12 volts. And then we can also accept, because these learners can also calculate the gradient, but after calculating the gradient, they can use the equation of a straight line, but with V and X instead of using, with V and X, yes, instead of using Y and X. So they will say 0 minus X will give 1 mark again for the gradient, correct formula there, correct substitution, 10 minus 0 divided by 1 minus 6. And then here we'll award a mark on the substitution, because if you can take a look at this substitution, it will be similar mark to the one that we gave there on the substitution, which is on the first option. And then EMF 12. And then the whole of that question will be 4 mark. And then 8.3, it says, how does the voltmeter reading change as the ammeter reading increases? And then write only increase, decrease, or remain the same and explain your answer. How does the voltmeter reading change as the ammeter reading increases? And then here, 1, the learner will get a mark if they say decrease, meaning the learner will have to say the voltmeter reading will have to decrease. And then why? Because current increases, that's where the second mark will be given. And then if they say I multiply by R, or V lost, or V increases, they'll get a second mark there. VI increases, and then the final mark will be if they show that V is equals to EMF minus the internal resistance decreases, meaning V external decreases, then they will get a second mark there, and then the whole of this question will be a 9 mark. Tatemo happy?
Thank you very much. I think at 8.2 million. Yeah, just for consistency.
Yes, Meneer.
Yeah, I think that mark will then have to move from the formula. And I will suggest with colleagues that we move that mark to the second substitution, maybe the numerator of the second substitution.
Okay, the numerator of the second substitution.
Yes, because that is where the unknown is, ne?
Yes.
Yes. Maybe you say one mark on the numerator and then the other mark on the denominator. So we remove a mark on the formula.
So meaning
consistency.
if we go to the accept, that mark will have to be on 0 minus x, le negative 2, 6 minus 0 there.
Thank you very much. Yes.
Okay.
Okay. And then another question, Ike? Is it? Ike, you have your hand up. Is it Ingrid? Sorry, Ingrid.
Ingrid, yes. Good day. Hello, meneer. Can you hear me?
Yes, we can hear you, ma'am.
One of my students with 8.2, I was now off for a while because it threw me out and then I had to join again. So I was now not sure if you guys already said that, but one of my learners by 8.2 they calculated the gradient, which they got then negative 2 ohm for, but then instead of substituting it into R equals to delta V over delta I, they use the equation for a straight line, y equals to mx plus c, and then they calculated the y-intercept, which represents the EMF. Can we also have that or take that as an answer as well?
Okay, I think, ma'am, we do have the second option where I said the accept, because I know these learners, because they know maths, they will want to use maths equation. Hence, I did not even give a mark on the V2 minus V1, because I knew that the other one maybe can use that one and calculate the y-intercept. I think that option is similar to that one. So you can
yes,
still get, they can still get the mark.
Okay.
Yes.
I see that. Thank you, sir.
Okay, perfect.
Thank you very much. And then Nomsa Secondary School, the question said ammeter reading increases. So we are supposed to give the mark for current increases. 8.3 Minier?
Or 8.3 Nemine.
Yeah.
Okay, yeah, I think I get what they're saying, because already we are told in the question that the ammeter increases. Ne? So I think here what we wanted to imply is that since the ammeter reading increases, we're trying to say that it increases as a result of current increasing. We thought maybe it might not be that obvious to every learner that ammeter is measuring current. I don't know, but I think we can look into that, Mark. But I get what she's saying.
Okay. Ke lebogile.
Okay, Dade, thank you so much. At question number 8.2, if the learner starts by calculating internal resistance and then substitute into the equation of EMF is equal to current into the bracket of external resistance plus internal resistance, calculating the external resistance aside, because then the learner will use the external voltage of 10 and current of 1 to get the external resistance.
Can you repeat the external resistance of what and what?
From the graph, learners can see there's external resistance of 10 and current of 1. And the learner calculates external resistance. So the learner will get external resistance as 10. And then adds that with the internal resistance, which they calculated from the gradient. And use current as 1 into the equation of that formula of EMF.
Okay,
Yes.
meaning they took the corresponding values for the external
From
and the
the
current.
graph.
Yeah, no, I think it makes sense. They got the correct answer, right?
Yes.
Yeah, no, I think you can send that as that option, but I think they are correct because they took in the corresponding values of the current and the external, yeah, and the external voltage. Yes.
Thank
yeah,
you.
and thank you very much.
Yeah, I think it's correct. You can just share it with us. Memo Malahlelo.
Okay, Memo Malahlelo.
I'm on 8.3. Yes, and May is correct to say we tell them that the current increases and we now award a mark on that. So I think we'll add the external, the V external will, we'll get back to it because it's the question.
Yeah.
But the V is on in the battery, anchor. So the V external will decrease also. So I think we can replace that I current, the current with the V external.
Yeah. Oh,
Yes,
okay.
I think we can,
but then the
replace it with
decrease
the
is
V
for V
external.
external, isn't it?
Yeah, the decrease, but
The decrease is for
bullet,
V external.
Bullet number 3, we have V external decreases. So hence I was saying maybe we'll look into it. Yeah, we'll look into it or now which one can we add there.
Maybe consider using that formula for constant what and what. You remember that? Because the EMF must be constant and the internal resistance there. Maybe that is what we can award a mark to.
I was also thinking of using the R total and the I current total, but now we only have the rheostat. So we don't have any other resistance. So
yeah, no, I think constant EMF and internal resistance, then yes, that can be the 1 mark. Okay. We have 8.3. If a learner said the quotient of the potential difference and the product of the current and the internal resistance, can I give a mark? Yeah. If a learner said quotient of potential difference and the product of the current and the internal resistance increases, okay, can I give a mark?
I don't get that one, Minia.
The quotient of potential difference and the current.
Can he send it to the subject advisor and then we'll
because it's V over I and the internal resistance increases. Maybe they should send it to the subject advisor. Please send it to your subject advisor, Lubabalo, so that we can have a look at it and then we'll revert back to you. Okay. Maile, do you still want to ask a question?
No, Minder. I was going to make the same suggestion that you made, rather than mark that current, where the current increases and V external decreases, we'll rather allocate marks to either EMF or to internal resistance remaining the same. So it is the same suggestion that you made. That
okay, no, thank you very much. And that Lekhooa, I do not see any other hand or suggestion. And by the way, NOMSA is not the person, it's the school. So I do not know, maybe that the person is asking a question from NOMSA is a male. So we are referring to him or her as a she. No, thank you very much. We can continue now.
No, thank you very much. I think 8.3, we've noted your suggestion that Mapi Lintate Maile.
And 8.2, ne?
8.2, yes, the tick for the gradient, ne?
Yes.
Okay, no, that is noted. Question 9, we are now entering into matter and material chemistry. The first question will be on atomic combination, and then The first question, 9.1, you will say define the term electronegativity for 2 marks. And then here, the question again, it's a 2 or 0, meaning we are having 2 or 0 on electromagnetism, as well as here in atomic combination. So the learner will be expected to say a measure of the tendency of an atom in a molecule to attract bonding electrons as stipulated in the examination guideline. So if the learner did not write that, then it means they will get a 0. Then 9.2.1, it says consider the molecule CH4 and NH3 and answer the following questions. So we are answering this question referencing to the 2 molecules given. The first one, which is 9.2.1, says identify the molecular shape of NH3 for 2 marks. So the molecule, they will have to be pyramidal. Therefore, the learner will get a 2 mark for being able to do the whole process of identifying that molecule by drawing the Lewis and then checking whether how are the lone pairs and all that, and then decide that it is pyramidal for 2 marks. And then 9.2.2, polar bonds do not always result in a polar molecule. So they are given a statement there to say polar bonds, they do not always result in a polar molecule. And then they say evaluate whether the above statement is true or false, and then explain your answer by referring to the above mentioned statement. So in this question, they will have to say the bonds between CH are polar due to the difference in electron negativity. So for saying that the bonds are polar, because they now have to evaluate the statement that was given. So to evaluate the statement, they have to now check the electronegativity in CH. Then they get that, okay, the bond will be polar. The 1 mark will be there on saying the bond will be polar. The second mark will be in them getting a difference, indicating that they got a difference there. Then that will be the second mark. And then the third mark will be in saying that the shape of CH is tetrahedral, meaning even though CH is tetrahedral, and because the charge distribution is symmetrical around the center atom of the molecule, this molecule is non-polar. So meaning the second mark, it will be in them indicating that CH, it's tetrahedral, meaning indicating the shape. 1, we want them to indicate the type of bond in the molecule. Number 2, we want them to indicate that there is electronegativity difference. Number 3, the shape. And then the last mark to say the entire molecule, even though the bonds are polar, but the molecule itself will be non-polar. So meaning that's how we'll allocate the 4 mark. Mark on the type of bond in the molecule and indicating that we are having that type of bond because of the difference that we are having between the 2 atoms there in the molecule. And then the third mark, the shape, and then the last mark, the molecule itself, showing that even though the bonds are polar, but the molecule is non-polar. So that's how we'll allocate that 4 mark. And the 9.2.3, it says, okay.
I still on the side, even 8, question 8, I saw on question 9. I don't know, is it my side only or what?
It is your side, ma'am.
I think just exit and enter again. Okay. Dadema, can I continue?
Yes, Ntate is just out for 2 minutes.
Okay,
you can continue, Ntate.
Okay. In an experiment, a learner at 9.23, in an experiment, a learner bubbles ammonia gas through a beaker of water. Will the ammonia gas dissolve in water? Choose from yes or no and explain your answer by referring to the polarity of the molecules. So in this question, what is happening in this experiment is that the learner is using ammonia gas through a beaker of water. Now, would the gas dissolve in the, meaning it's testing whether will that ammonia dissolve in that particular water. So how is the learner going to be awarded mark? 1, they must say yes, the ammonia gas will dissolve in water. Why? Because this is solubility. both NH3 and H2O are polar molecules, and therefore NH3 will dissolve in H2O. Because of the molecules, they are both polar. It means that NH3 will be able to dissolve. So it simply means that if they were not both polar, then it was not going to dissolve. So 1 mark will be on yes, and then the second mark will be on the substantiation that the learner is doing. Then that's how they will get the 2 mark for this 9.2.3. And then 9.3.1, a grade 11 class decide to investigate the effect of bond order on both bond length and bond energy. The theoretical data collected is shown in the table below. Now, in the table, we are given bonded atoms, bond length, and bond energy. In 9.3.1, it says identify the independent variable there in that particular investigation that the learners are doing. So at 9.3.1, the learner, by just saying bond length, they will then get a 1 mark for that particular question. So 9.3.2, it says, apart from the bond order, name 2 other factors that influence the bond energy. So what else can influence the bond energy? The learners, they must know that the bond energy at 9.3.2 can be influenced by atomic radius and the difference in the electronegativity. Then the whole of question 9 will be 13 marks. Thank you, Memo. Anything from your side?
Okay, I have Rochelle here. Rochelle with a hand and then followed by Lekhooa. So Rochelle, you go first.
Yes, Emma, sorry, I'm now in my car. I hope you guys can hear me. I just want to make sure at 9.2.1, if that must not be trigonal pyramidal, the shape that we have to answer. 9.2.1.
9.2.1.
Yes.
Sorry, can I come in? It is, yes, it is supposed to be trigonal and pyramidal.
Okay.
And I want to ask, so that's 9.2.1, the word trigonal pyramidal. That one word is just left out there.
Okay.
And then Emma, in 9.3.1, we are investigating the bond order. We're changing the bond order and then looking at how it affects the bond length and energy. So should the independent variable not be the bond order instead of the bond length or the bond energy?
I think she's right, ma'am.
Yes, then it will be changed to bond order.
Yeah.
Okay, thank you, Emma. That's all for me.
Okay, LM, Lekhooa Tate Kapome, sorry.
Afternoon, colleagues. Okay. I just want to ask concerning question 9.2.2. Can the presenter kindly go to 9.2.2?
9.2.2, okay.
Yes. Concerning the shape of stage 4. If a learner spoke about, instead of speaking about charge distribution, if a learner maybe talked about the dipole moment to say that for CH4, the net dipole moment is 0. Can we accept that?
Yeah, I think we can. Yes.
Okay, and Ntate Lekhooa, on the chart here, the questionnaire 922 says state whether the statement is true or false. So it is not indicated on the memo, of which the first mark must go to either true or false. Then
Okay,
the 3 marks for the...
It's supposed to be true there. I think we'll also rectify that.
So colleagues, you have to write true and then 1 mark for true, and then the marks will be reallocated, especially for the explanation. And then we also have 931 is you did attend to it. The answer is bond order. And then 923 is the second mark for NH3 and H2O are polar molecules only, or the whole statement. So can you go to 923? Is it for the whole statement, that mark, or what? Or NH3 and H2O are polar molecules only?
The mark was for the entire explanation, because I care for the fact that they are polar. Therefore, they must conclude that it will dissolve in water. So it means that is the learner concluding there at the second bullet. So the one mark was for the entire explanation, meaning the conclusion.
So there's a suggestion here. They say, can we agree that the second mark be given to NH3 and H2O are polar or have the same polarity, and stop there without repeating the question by saying NH3 will dissolve in water?
Okay, no, it's fine, but I think they are still capturing what is it's given there, but we'll remove that last part there.
We have Ilke and followed by Lebohang Maile. Ilke Minar.
Good afternoon.
Afternoon, ma'am.
I think it was mentioned in the chat somewhere, but I'm failing to see now. If we are saying that 9.3.1 should be the bond order, the independent variable, then at 9.3.2, can we then not also accept bond length? Because bond length will also be, because 9.3.2, the question says, apart from bond order, name 2 other factors that will influence bond energy. So then bond length also becomes something that will influence bond energy. So atomic radius, bond length, and difference in electronegativity.
Okay.
Yes.
And then,
Ma'am Alahle,
Mr. Lebohang?
yes, I was saying we can accept that bond length, yes.
Okay, I had a similar question to the previous speaker to say one of the factors, I can in question 932, we just want factors that could influence bond energy. So I was saying as part of the memo, bond length should also be included. Because though it is not, it is the one that is not investigated here, but it is also a factor that can influence or affect the bond energy. But the one that is being investigated here for the one that will be, or for the one that we will identify as the independent variable will then be bond order. But as one of the other factors, besides electronegativity difference, your bond order, as well as atomic radius, then bond length can also be affected, though it is investigated.
That's why we are saying we accept it.
So, which means 931, we accept both bond order. Answers will be in the memo.
Sorry, ma'am.
Okay. Carry both bond orderly, bond length will be in the memo.
No, I take a bond order, it says apart from bond order. So the question says apart from bond order. So we'll accept bond length.
Okay. Tate Maile.
Yeah, ma'am, I was just saying for 932, that's where we'll accept bond length. I can't that Lekhooa.
Yes,
and then for 931, it's about bond order.
Yes, yes. Now Tate Maile, we are on the same page, ma'am Alahle.
Okay. So can you clarify it for 9.31? What do you accept for marking purposes?
9.31, instead of bond length, we are taking bond order there. And then 9.32 will accept bond length, atomic radius, and the difference in electronegativity, meaning we'll add the third one there. Because I think they're saying name 2 other factors. So meaning if the learner either said bond length and electronegativity, they will get a mark. If they said atomic radius, meaning any of the 3, if they mention 2 of the 3, then they get a mark.
Okay. And then we also have Karabelo Molife says, same in 931, he says, if a learner used the information from the table and wrote bonded atoms, do you accept?
No, but those bonded atoms, the learner must know that if atoms are bonded like that, that is bond order. So I feel the learner must be specific to say it's bond order because, yeah.
So
I don't think
you're
we
not
must
going to
accept.
accept.
Yeah, we're not going to
Not
accept.
accepted in that teacher Molife. And then in that Maile, is it the whole old hand? Tate Maile? Okay, Tate Lekhooa, nothing from the side. You can move on to question 10.
Okay, question 10. Colleagues, question 10 is the last question that will be assessing physical properties. The statement says the graph below shows the boiling point versus molecular mass of group 15 and group 16 hydrates. So we are investigating here the group 15 as well as group 16 hydrates. Now, first question says, define the term boiling point. So for this definition, again, it's a 2 or 0, meaning after electromagnetism, the definitions that we are taking now on the other questions is 2 or 0, but not part marking. Now, at 10.1, we are expecting the learner to say the temperature at which the vapor pressure of a substance equals atmospheric pressure. So that will be 2 marks. If the learner omitted something there, maybe vapor pressure, we can't get 1, so it will be 0. And then at 10.21, it says from the graph, write down the formula of the hydrate with the highest vapor pressure. So colleagues, if you look there, for the hydrate with the highest vapor pressure, it will be the one that is having there the lowest boiling point. That will have to be pH 3, then we'll allocate 1 mark for that. And 10.22, from the graph, write down the formula for the hydrate that requires the most energy to undergo a phase change. So the hydrate that will require the most energy to undergo a phase change, if you look at the graph, that will have to be water there because of its high boiling point. Then the answer there will be water. Then we'll allocate 1 mark for that. And then 10.3, explain the difference in the boiling points of H2O and NH3 for 4 marks. So here, colleagues, how are we going to allocate marks? Number 1, NH3 and H2O has hydrogen bonding between the molecules. I think we'll have to give it 1 mark there to indicate that NH3, meaning and highlighting that NH3 and H2O, they are having hydrogen bond. You'll have a 1 mark there. Then where will the second mark be? NH only has 1 lone pair, whereas H2O has 2 lone pairs to form more hydrogen bond. So here where they are indicating that because of the difference in the number of lone pairs, the other one is having 1, the other one is having 2, therefore will award the second mark there. Or if the learner says NH3 is less polar than H2O, so meaning if the learner is indicating polarity there by also saying the difference in the electronegativity difference in H2O is greater than in NH3. So we mark another mark there. So we must take it into consideration, colleagues, that here there's an or part, meaning the learner must say this or that, or any of the 3, but we will not award 1 mark for one of the 3, but it's any of the 3. So it's very important to note that that will be the second mark. And then the third mark, when the learner says the strength of the intermolecular forces will be greater in H2O, or the strength of the hydrogen bond will be weaker in NH3. Therefore, we'll also award a mark there by the learner indicating that the strength of the intermolecular force will be greater in H2O, or if they say will be weaker in NH3, that's why we'll award the third mark. And then the last mark will be where they are saying more energy is needed to overcome the intermolecular force in H2O as a result of having stronger intermolecular force than NH3. Hence, water has a higher boiling point than ammonia. And then that's where the last mark will be allocated in that question 10.4. And then on it say, it's 10.4. Yes. And then on It's 10.3, right?
Yes, it
10.4.
is 10.3. You have to move on to 10.4.
10.4, yes. Now, identify and explain the trends in the boiling points from pH3 to SBH3. So here, colleagues, how are we going to allocate marks? Where the learners now they're explaining the trend. Number one, they have to say they have the same intermolecular force, meaning by the learners indicating that from pH3 to SBH3, the intermolecular force is the same there. I think we can give a 1 mark there. And then the second mark will be in them saying that the molecular mass increases, meaning when you move from pH3 to SBH3, the molecular mass increases. That's where the second mark will be. And then the third mark will be in the strength of the intermolecular forces increases as the molecular mass increases. So we'll give the second mark there to say, as a result of the molecular mass increasing, it means that the strength of the intermolecular force will also increase. Then the last mark will be in saying that more energy is needed to overcome the stronger intermolecular force, therefore an increase in boiling point. There will be an increase in boiling point, meaning we are giving here the last mark on the learner indicating that more energy will be needed to overcome the intermolecular force as you move from pH3 to SBH. And then that will be 4 mark. And the last question will say 10.5, what can be concluded about the effect of molecular size on intermolecular forces? And then give evidence from the graph. So here we are expecting the learner to say, number one, larger molecules have stronger intermolecular forces, meaning we expect the learner to indicate that they understand that as the molecular size increases, the intermolecular forces are getting stronger and stronger. That's why we'll give the 1 mark. And then the last mark will be on saying that because the boiling point increases as the molecular mass increases, therefore that is what we can deduce from the graph. So that's where we'll allocate the second mark. So the whole of that question 10 will be 14 marks, and then the whole question paper will be out of 150. Memo Lahlela?
Okay, we have a question on the chart here. It says 10.3. Can you go to 10.3?
10.3.
Second mark, which marks a structural difference. The second mark, what
Yes.
if learner says H2O has more molecular mass than NH3?
No, but I think in this instance, we are looking at the polarity there in terms of the difference that we are comparing in the two structures. I think I don't know, what do you think, when we can accept, but I think we must not accept because we are looking at the polarity of the molecule.
Instead of the molecule.
Yeah, instead of the one that bring in the difference there. I think we must not accept the molecular mass.
Yeah, I also agree with you. We rather focus on the electronegativity there, the difference in the electronegativity. So Ndate Tekiso, not accepted. I don't see any hand or anything from my side. So colleagues, I think we have reached the end of the Ndate Tekiso. Do you want to say something? Go ahead.
Yes, thank you. Just as a follow-up so that we also teach.
Can you raise your voice in that we are old, we can't hear properly?
Okay, I'm saying just as a follow-up for teaching purposes, and there is nowhere where this question is limiting one to go to any structural difference. So what qualifies us to say we would not ever be looking at molecular mass? And I need this explanation specifically for teaching purposes as well. Thank you.
Okay, that we also have Emma. You're back?
Yes, I'm back. I just want to check with you, colleagues. Say on the same point, because here, what is the independent variable? So we are not specific. Maybe if we had said to learners and then we are specific referring to intermolecular forces or referring to to polarity, then we'll say it is limited to only to those. But if it is open like it is the case here, for me, I think we should accept as long as that then brings the difference in the strength of intermolecular forces.
Okay.
Also on 10.4, I really do not see why we give a mark for learners saying the same intermolecular forces, because the question says identify and explain the trend. So I think the first mark should be when a learner identifies the trend saying boiling point increases from pH3 to SbH3. Then that will be identification of the trend. Ne? And then they talk to molecular mass increasing, strength of intermolecular forces increasing, and then more energy required to overcome the strength of intermolecular forces. I think that is where the mark should be. But saying they have the same intermolecular force, I doubt we'll have learners giving that. Yeah, those are the two contributions, colleagues, that I want to make. Yeah.
Can you show the memo, Ntate Lekhooa?
Okay.
Can't see the memo.
All right. And Ntate Mohapi, can you repeat them again? I think in 10.3, on explanation that in the question would not indicate that they must refer to polarity. In that sense, as it was the explanation that Tunzi also wanted at the issue, I think we can accept it based on the explanation that you have provided, because on the question, it was not specific.
Yes, Minir, that will be my suggestion. And then 10.4.
Yes, can you also
did you get that?
10.4, what were you saying?
I'm saying the question says identify, ne? Identify and explain the trend in the boiling point, meaning the first thing that the learners are expected to do is to identify that trend. So for me, that didn't deserve a mark. If a learner says from pH3 to SbH3, boiling point increases. That is what we want. And then the explanation will be the molecular.
Can you go to 10.4, Ntate?
Oh, 10.4, I mean, excuse. 10.4.
Ntate Lekhooa, show us 10.4.
It's like 10.4.
Yeah. Then we say molecular mass increases, strength of intermolecular forces increases, more energy is needed to overcome the strength of intermolecular force. Then we remove that mark, yeah, they have the same intermolecular force. I don't see the relevance of that point on this question. Because the independent variable, what differs from these molecules that we have here is the molecular mass. So that is what the learners will focus on. And then how does that then affect the strength of intermolecular forces and the amount of energy that will be needed to overcome those strength of intermolecular forces? I do not know if you hear me, Minia.
No, I hear you. Come on, Soma, we must substitute that they having the same intermolecular force with energy as a point.
No, with from pH3 to SbH3, boiling point increases because that is the trend. That is what is happening again.
Increases.
Okay, yes.
Boiling point increases, and then we do that, and then maybe we'll have a second option where now we do the opposite from SbH3 to pH3. Boiling point decreases, and then we just do the opposite of everything.
Okay, no, I think I get you that.
Okay, thank you very much.
Okay, thank you, Ntate Mohapi. Ntate Thabang, we also have Mr. Moeketsi Hlahani in the chat saying, when the intermolecular forces are the same, isn't it advisable to compare molecular masses? Because that's how it's done when the forces, I don't know, and then,
Kele? I think Ntate Mohapi mo capturile Ntate o a gawileng.
Okay. Tate Kele, after Kele, we'll give to Memanchu. Ms. Khalo?
My question on 10.4 was then, are we marking when learners are going to say boiling point, or are we having option of saying they have the same intermolecular force, we give all marks? or are we now restricting to learners referring to the boiling point? Are we accepting both? Is it additional?
Oh, okay. Yes, I think Memanchu will come in and assist us. I think she will explain it clearly or now. How should we go about it? Because a point that is made by Ntate Mohapi Kore, he was saying because of the trend, there's no necessity for mentioning that they're having the same intermolecular forces. So I think we'll give Memanchu maybe to try and clarify for us or now, should we take out same intermolecular force or it should be another option?
Memanchu, over to you. Memanchu? Memanchu? But the suggestion, while we're still waiting for Memanchu, the suggestion was we replace the first tick with the answer. The learners must refer to boiling point.
Yes.
Yes.
Can you hear me now?
Memanchu?
Can you hear me now?
Yes, you are audible enough.
Apologies, colleagues. Old age. I forgot to unmute. I was saying in 10.3, because of problems in connectivity, I'm not sure what was the final decision in terms of, was it we accept the molar mass increases?
Yes,
what was on the in 10.3?
Yeah, in 10.3, they were saying since we did not restrict the learner to only maybe speak about polarity, so if the learner wrote even about the mass, we can accept.
I would like to disagree on that one.
Okay.
Remember, NH3, the molar mass is about 17, H2O is about 18. So they have comparable molar masses. So really, the only difference is that polarity. So I would like us to remain with the memo as it is and not accept the molar mass.
And then in that case, Ntate Tekisho, ona kopile hore, can it be clarified for when they are going to the classroom, or now how can they make it clear to the learners that even though it was not said polarity should be considered, how would the learners know that they should not consider the molecular mass in that instance?
It should be, even when the teachers are assessing their learners, they should make sure that if the intermolecular forces or the strength of intermolecular forces differ, they must ensure that at least for them to be able to mention those strength of intermolecular forces, the molar masses are kept comparable. Because if they are not comparable, then we are now going to have two independent variables. So always make sure that they are around the same figure. So in this case, because they are around the same figure, the difference is because of the difference in the
polarity,
the strength of that polarity. Yes.
Okay, so but I think to take issue, I think now you will understand it, or we must check the mess. Okay, thank you very much on that 10.3, 10.4.
10.4, because some of the teachers, I think they would really like the learners to say they have the same type of intermolecular forces. And due to the fact that they have the same type of intermolecular forces, then they have to check the molar masses. So can either mention the same type of intermolecular forces or the boiling point. Because I think in this case, it's also emphasizing the fact that which one are you keeping as a control variable? Just like in 10.3, you are saying that the molar mass is kept as a controlled variable. So in this case, they are keeping the same type of intermolecular forces. So if the learner mentions it, and it doesn't really hurt. So I think we can keep both.
Okay, so meaning we must make an option where the learner will start by saying the boiling point increases.
Which question?
Or 10.4, we are still, I can't that hapuna he feels sorry. That 1 mark that we gave there on his option, he was saying maybe the first mark we can say on the trend, the learners must say the boiling point increases, and then from there they mention now the molecular size increases, the strength, and so forth. He was saying that he feels we should mark it that way there when we replace same intermolecular forces.
Yes, we can keep that as the 1 year boiling point increases as our main answer. But is it wrong really for the learner to say it's because I've kept my the intermolecular forces are the same, or the same type of intermolecular forces? As a result, I'm having a look at the molecular masses. But I tend to, now that I'm thinking of it, I tend to agree with Ndatem Happy. So yeah.
So
let's stick with what Ndatem Happy is saying.
Can you clarify me? Meaning we are sticking with boiling point increases.
Let's not accept same type. Let's move the mark to that one and not accept the same type of intermolecular forces.
Okay, no, thank you very much. I think it's clear because we wanted at least the colleagues to be clear which one are we marking as the mark. So meaning same intermolecular forces, Mescalo, we would not take.
Say that again.
We will not accept same intermolecular forces.
Okay. Tatemo happy, and then after Rochelle, Rochelle van Rienen. Tatemo happy first.
Yeah, no, I think I'm covered. But to learners, you see 10.3, that difference of 1 or 0.2, to them is a difference. And I think that is how some learners will identify it. But it's okay for future teaching. I think that is how we should go. Ne? Thank you. Yeah.
Clarify happy. Remember this is a build up to grade 12. Grade 12, even when we compare, they will be around the same value, but they won't necessarily be the same value. Difference about 1 or 2 we accept as being comparable.
Okay, thank you, Memo.
So we say, thank you, me.
Rochelle.
Afternoon, colleagues, again. I just want to make a suggestion. If we start with saying that the trend was the increase in the boiling point, we give a mark for that. And we give a mark for they have the same intermolecular forces, but then we combine that bullet number 2 and 3, where we say, as the molar mass increases, the strength in the intermolecular forces increase. Then those two actually go hand in hand, and then we can add the energy, because the learners are so used to also talking about the energy and having to say if the molecular forces are the same or not, because then we gave a mark for the bonds, hydrogen bonds being the same in 10.3, but now we do not give a mark for it. So I have a suggestion that we give the trend, the energy that's in the boiling points are increasing, and then we still give a mark for they have the same intermolecular forces, but then they have to say as the molecular mass increases, the strength of the intermolecular forces increase. That is then 1 mark. And then the 4th one, more energy needed to overcome the stronger forces.
Memanchu, can you assist us there?
I was still trying to write it down. The first mark will be for boiling point increases. The second mark, they have the same type of intermolecular forces. And then the third mark will be?
The
As the
second mark,
molecular mass increases, the strength of the intermolecular forces increase.
Meaning bullet 3.
So
2
actually
and 3
bullet 2,
becomes 1. Are you saying
yeah,
bullet 2
no,
and 3 becomes 1?
2 and 3 basically, yeah, is the same thing. Where you compare that the increase in molar mass causes an increase in the strength of the molecular forces.
Yeah, bullet 3 also says strength of the intermolecular force increases as the molar mass increases. So the second statement is repeated on the third statement.
Yeah, so basically, if they just give you 2 and 3 combined, where they show as the one increase, the other one also increase, then that can be only 1 mark there. Then we're still back to 4 marks.
Advice?
Yeah, I'm still trying. Is there anybody who has another question? I'm still trying to think about it.
I think now my suggestion is that because the way we mark, we expect grade 12s to give answers. The first one, they indicate the trend. The second one, they indicate the type of the intermolecular force. And then the third mark we give for the strength. Then the last one for energy. I think we should be consistent. And then I support Rushal's suggestion. That's my take. Dr. Tekiso's hand is up.
Okay, yes, I was just saying, as Manchu is still marinating the thoughts, we must still remember we have 1 mark that we still need to allocate. That comes from like us electricity. So put that also in mind when we are removing marks and adding marks here.
Mame, the first mark, it is on the trend. I care they're going to indicate what happened with the boiling points. I care. And then the second one, it is on, they have the same intermolecular force. The third one is the strength of the intermolecular force increases as the molecular mass increase. The fourth one is on more energy is needed to overcome strong intermolecular force. So we're still waiting for Memanchu to give us the final verdict that they take issue.
Malashela, one more thing that we usually teach and guided on Hore, immediately when these intermolecular forces are the same, we need to independently mention what it is that is a structural difference. Okay, so I don't know there, because the structural difference, according to me, would be the second bullet, independently of the third one, because the third one is also a comparing of the strength, though we are trending it, and then the last one. So I possibly, if really, because what I've been looking at from paper 2 is that most of the time it's the examiner's choice not to mark the same type of intermolecular force, either it being mentioned or not being mentioned. So it's usually their choice to say we want to mark it or not. So again, here, my suggestion would be, let it also be a thought in the examiner's mind to say, now this time, do I really want to mark that the forces are the same, the first bullet actually, and then 2 then being the same, what is this structural difference that is there? Then let me compare the intermolecular force strength, and let me also talk about the energy. Then it would easily take this question to 5 marks, if that is the thinking. But it's the choice of the examiners and the moderators. Thank you.
Okay, Memanchu, thank you, Tate.
Colleagues, I'm thinking, because Lelena is reading that from the table. Ne? The mark of boiling point increase is important as a graph interpretation. But in most cases, we don't give a mark for the same, they have the same type of intermolecular forces. Because learners might say the molecular mass increase. And then in the next one, they will just say the strength of intermolecular forces increase without mentioning that as the molecular mass increase. Anyway, if we mark it under different bullets, even if the learner says the strength of intermolecular force increases as the molecular mass increases, it will be 1 mark for strength of intermolecular forces increases and 1 mark for molecular mass increase. So let's remove the mark of the same intermolecular force, because in most cases we don't give that mark anyway. So it will be 1 mark for boiling points increase, 1 mark for the molecular mass increase, 1 mark for the strength of intermolecular forces increase, and the last mark for the energy needed to overcome the intermolecular forces.
Okay, thank you, Memanchu. Memanchu, I have a question for teaching purposes. In grade 12, we put more emphasis on the type of intermolecular forces and whereby the learners are awarded marks. So in this case, in grade 11, it's not important to know the type of the intermolecular force or to mention it.
Let's differentiate, Memalahle. If they have different intermolecular forces, then you'll mention intermolecular force of one compound and intermolecular force of the other compound, and then compare the strength and then the NH. But if they have the same type of intermolecular forces, you mention the difference. So you don't mention would they have the same type of intermolecular forces. You mention the reason why the boiling point will be different. So the boiling point will not be different because they have the same type of intermolecular forces, but the boiling point will be different due to the fact that the molar mass has increased. And then you mention the strength of intermolecular forces and the NH. The same, when they have different types of intermolecular forces, the boiling point will differ because of the strengths of those different types of intermolecular forces. So you first mention those intermolecular forces because they are different, and then you mention the strengths, and then you mention the NH. But if they are the same,
oh, we lost Memanchu. Oh,
he's gone. I don't know whether you can still hear me.
No, we could not hear you. Hey, just give us the last statement, Mme.
I think I've summarized what I was saying, Memalahle.
Yes. Okay. Okay, colleagues.
If we mention different, repeat. If we have different types of compound with different types of intermolecular forces, we mention those intermolecular forces. They get a mark for each type of intermolecular force. Then you'll mention the strength of intermolecular forces and the NH. But because the intermolecular forces are the same, you mention what causes the boiling point to be different. In this case, it will be the molar mass. So that's where the mark must be. And then when the molar mass is different, how that affects the strength of intermolecular forces, that's a mark, and the energy needed to overcome the intermolecular forces. Thank you.
Okay. Thank you very much, that Memanchu. I hope teachers took note of that. I think we have reached the end of the discussion. Thank you, colleagues. Don't forget to complete the attendance register. Tate Lekhooa, last words.
Memalahle, ke utlwile hanyane Ntate Thekisho, you were saying that we have a 1 mark that is not allocated. So I wanted him to clarify that, because I think the 1 mark that we had challenge with is the one where we said we'll talk about constant EMF as well as internal resistance, or remaining the same. So I wanted him to just, before we conclude, to indicate which mark was he talking about.
No, he was referring to this 10.4. And then Tate Thekisho will talk to you, Gaga Tuko, just to clarify the term. Mekele has a hand.
Okay, Mekele, a hand.
I think while I'm listening to Memanchu, now I'm sorry, but I'm gonna revert back to 10.3. I think she said we should not accept the difference in the molar masses because of that 1 mark, which seems to be comparable. But then it also sounds like a contradicting statement, because a learner, like Mr. Mohapi was saying, a learner would see that nitrogen mass is less than that of water. at that 10.3, the second mark.
Can you take us to 10.3, Ntate Lekhooa?
I'm going
Yeah,
there.
because I feel that it's very disadvantaging learners, because the statement from the question itself was not clear on 10.3, just said explain the difference in the boiling points. So if the learner is looking at this, the learner can see the molar mass of water is 18, the molar mass of ammonia is 17, and the learner uses that as saying both, because now both of them are having the same hydrogen bond. What is it that is making them not to be the same is their molar mass. But then Memanchu here at 10.3, the second mark, said we should not accept the molar mass. The learners see they have the same intermolecular force, only difference is the mass. But the verdict she gave for 10.3, the second mark, was on the polarity, but the question did not restrict learners to use polarity. And the explanation that I'm listening to her on 10.4 now makes marking of 10.3 to be a little bit difficult.
And Ms. Khalo, I think what Mem Manju was saying, it was on when she's talking about for teaching purposes for the future. But I think on 10.4, she concluded one, we'll talk about increasing boiling point, talk about molar mass increasing, strength, and then the energy. I think she concluded on 10.4. But what she was saying, she was talking about how must we teach the learners going forward. Unless if I don't understand what you are saying.
No, the teaching part, I think when I go back to learners, I'm going to tell them, once you identify that the forces are the same, then tell us what is causing the difference. So at 10.3, the learner can see that both ammonia and hydrogen have hydrogen bond. They are the same. Next point would be the learner must then tell me what is causing the difference. According to the learner can see that ammonia is having a molar mass of 17, whereas hydrogen water is having a molar mass of 18. That is the difference that the learner can see, even though they are having the same intermolecular force, which is what Memanchu was saying at 10.4. The learner will see the boiling point is increasing, yes, and the learner will say they have the same intermolecular force, yes. What's causing the difference? Changing the molecular mass, which is also applicable to the second mark of 10.3, where previously we had agreed to say we will give a learner mark if the learner is referring to the molar mass. But then the verdict that Memanchu gave us was no, let's stick to polarity. My question is, the question paper is not clear. The question paper did not guide learners to state. It just said, explain difference in boiling points. It never said referring to. The question did not guide learners. It was just an open statement. I'm referring to the second mark of that 10.3. Because the second mark of 10.3 is either the learner talk about changing electronegativity or which one being more polar than the other. For teaching purposes also, and understanding when one has to mark, and consistency. If we are saying we're being consistent at 10.4, then the same consistency, I believe, must be applied at 10.3.
Ms. Khalo, I think it is noted we have to be consistent in both 10.3 and 10.4. Can we hear Ntate Hlahane? It's getting dark outside. Ntate Hlahane?
Good afternoon, colleagues.
Afternoon, Ntate.
With regard to 10.3, the same thing. I've raised the issue, or I've typed in the chat box that how would we answer the question if we were comparing HCl and water? I didn't want to say HCl. I wanted to say hydrofluoric acid, which is HF. HF and water have the same intermolecular forces. So if we were to compare based on the molar masses or the molecular sizes, molar mass of HF is 20 and of water is 18.
whereas HF has the lowest boiling point compared to water. Meaning when the forces are London forces, it's incorrect for us to compare using molecular masses. That is what I wanted to raise. So I don't know why.
Thank you, that.
Okay. Ms. Khalo,
Okay.
can I come in?
Memanchu, I wanted that Memanchu to clarify 10.3 also, like she did with 10.4. Or do you have something to say, Ntate Lekhooa?
No, Nekere, I think that I buang it's clear to say we should learn or teach the learners on now. When are we focusing on the for this question at 10.3, the polarity, and when are we focusing on when we are not focusing on the polarity, which is when we are focusing on the molecular size? Because I think that is mentioning a very important point where he's talking about the London, to say when we are not comparing the London, we cannot talk about the molecular mass, but we can only talk about the molecular size if we are comparing something that has London, if I get that correct.
Yes, you're correct, Minya. That's what I want to say.
Yeah, because I think that will clear the confusion at 10.3, bullet number 2, to say, because there we have hydrogen bond, that is why we should not be comparing with the molecular mass. I think Memo Jubat can come in and clarify it further, but I think that's the point that was trying to make.
That Takisha is saying in the chat, we did in March 2026 to give a mark for London forces for both in paper 2 grade 12. So, Memanchu?
Consistency.
Can colleagues, now that we lost Memanchu, it seems like we lost Memanchu, so can we close the meeting and then Memanchu will give us a response? Or okay, there she is. Memanchu? Unmute Lebu. I don't know what is happening with her. I think it's a connection.
I think it's a connection issue.
Colleagues, can Memanchu will write down that whatever that she was going to say, and then we'll share it with you in the groups.
Yeah.
It's already 5:10, colleagues. Other colleagues, I had to catch the transport. So colleagues, we're going to close the meeting. Thank you very much for participating. Thanks to the team that set the paper, and then Ntate Lekhooa, your last words, and then you close the meeting after. Thank you very much.
Okay, thank you very much, Mema Lahlela. My last words, I just want to say to the colleagues, good luck with the marking, and then thank you very much for the input that they've made. As I've indicated earlier, that we are here to grow together. I think what I'm observing today or learning is much on us growing as a team. And I think for me, that is the highlight that I'm taking from this session. So colleagues, good luck with the marking. Remember that by the 26th, we must be done and submitted everything as per the LTA. I want to declare this meeting adjourned. Thank you very much.
Thank you, colleagues. Bye. Tatema happy you.
No, it's technology, skis.
Okay, bye-bye, colleagues. All the best with the marking.